Welcome to Sysinternals at 25. I am super excited to be here. I've got Mark Russinovich with me. How you doing, my friend?
Doing great, Seth.
Legal driver and cheap insurance now for Sysinternals. Is that right?
Yeah, it's great. It's grown up. It's all grown up.
So I want you to get into the history of Sysinternals, because my understanding is, because I did a lot of research, I read the Wikipedia page yesterday, that it's changed names over the year. Tell us about the history.
Well, so I've always been interested in operating system internals and then writing tools to explore it and to take advantage of that kind of knowledge. I started to do that in high school, and then I went to undergrad, went to get my PhD in computer engineering and met somebody named Bryce Cogswell, who becomes key to the story in a few minutes. But we started working on products as part of a startup that we came up with idea that involved leveraging Windows internals, both Windows 93.1, Windows 95, and Windows NT. And so I started to learn about internals, and then I said, hey, I can actually understand better registry monitor. And started to say, hey, Bryce, hey, we can write more of these kinds of tools. And so we started writing more tools like that. FileMon followed that. NTFS DOS is a tool that we wrote that runs actually on DOS, but lets you mount NTFS volumes that were created by Windows NT. Mm-hmm. And we started to continue making these kinds of little utilities. We decided, hey, let's publish these. So I had a friend named Andrew Schulman who wrote this book on undocumented Windows 95 that was really popular at the time, made him unpopular with Microsoft. Right. But I'd gotten to know him, and I said, hey, you've got a website, how about if you post these tools up for us? And so we started to do that, and then I'd say, here's an update, and he'd say, okay, I'll get around to it, and a few weeks would go by and he wouldn't post it, and so I'm like, okay, we need to take this into our own hands. Bryce, let's put up a website, and so we put up ntinternals.com and started publishing the tools there directly. And so that was September of '96 when we launched that domain, ntinternals.com, and started publishing the tools. And we launched with 4 or 5 tools that we developed over that year leading up to that.
So let me ask you a question. So basically this was born out of a curiosity for the internals of an operating system. You're like, I'm gonna write some things to visualize. Obviously the registry was a scary place back then where you don't want to change stuff, and you visualize certain things to help you, and decided to release it.
Yeah, I mean, it was really kind of fun because I love the multi-purpose aspect of things that I do where I'm getting multiple uses out of it. In this case, I was learning about the operating system, just writing the tool. And then the tool itself would teach me more about it, and then other people would find it useful too.
And so there was a bunch of tools, like you mentioned just a couple of them. Tell me, what were some of your favorite ones to work on that you learned the most from?
Well, Regmon and FileMon were both fun because they both showed operating system internals, but took 2 different approaches. On FileMon, Windows had this built-in system for intercepting file IOs that antivirus drivers would use. But there was no example for how do you monitor what's going on. And the documentation for it was pretty lame. At the time, there's something called the IFS Developers Kit, Installable File System Developers Kit, which didn't really talk about doing filter drivers, as these were called, very well. So I had to reverse engineer a lot and experiment a lot to get that running, but it leveraged mostly, documented, kind of semi-documented Windows something for Unix of patching the system call table. For example, when you call open file or the open API, it goes into the kernel, and then the kernel through a index, right. And the open function in the kernel is called through that index. And if you replace that index with a different function, then the kernel will call that function instead. And if you record where it was originally pointing, the original open call, you could point it at yours, do some stuff, call the original one, get back what the result was, and then return. This is called system call hooking. And so I did that for Unix, and then I'm like, I can do this for Windows too. And so I came up with system call hooking for Windows NT to develop Regmon for it. So 2 different approaches, and required me to be a little creative about how I could get that kind of visibility into the operating system.
So you were doing like some crazy pointer arithmetic then for the system calls as they were going in the kernel.
Yeah,
is that right?
That's right.
That's really cool. Look, I took an operating system class. I didn't know I had 24 hours 26 hours in a day to write operating system code because it was that bad. How deep did you have to get into things to make this work? Because you're looking at the system call table, which is literally how things happen in the kernel.
Yeah, so a lot of this stuff wasn't documented, of course, because it's so low level and no reason to document it for the average developer. So I did a lot of reverse engineering. And I reverse engineer it a couple ways. One is I would have a kernel debugger, and it's kind of ironic because I started to use this tool called SoftIce, which had debuggers for DOS and then Windows 95, Windows 3.1, Windows 95, and Windows NT. I ended up joining the company that made that, New Mega Technologies. But that's the tool that I used, and I actually wrote some APIs for it and wrote documentation for it after I joined it. But that's the tool that I used to set breakpoints and then say, oh, the operating system is doing this, now it's doing that. And then I also used static analysis, where you can take the binaries and then disassemble them, which means translate them into the assembly language. And then I could study that and also kind of get a view of where things were. And Windows, the kind of cool thing about Windows is it came with symbols, at least for what they call public symbols. So for kernel APIs that were public, that when somebody's debugging something would help them understand what's going on in the kernel, those symbols I could map into the disassembly. And then I could say, oh, here's the create function, and it's calling the allocate memory function, and it's, I could follow my way through the system that way.
So you're not just looking at jump calls and addresses, because that would be terrible.
The thing is, the private APIs didn't have symbols, so that I did a lot of that too. Like, what is it called? What is this function doing? And then I'd give it my own name so I could track what it was going on.
I remember when I did my operating system class, I asked my professor, hey, can I use C++? And he laughed at me. He's like, if you get it to work, great. So you were literally like in C and lower level code to get this to work, because there's no other way to do it.
Yeah, this is assembly language, which is, the low level CPU instructions just in a human readable form. It's not binary, but the next level up from that.
It's like move this thing, address, jump, this thing, address, and it's that low level. Now, as you're debugging these things, are you actually jumping through the actual assembly?
Yep. And then you're looking at the register set, and you're looking at memory to see what changed. And
so we mentioned a couple of tools. Are there any tools that were inspired other than looking at the system calls where someone asked you for something, or you're like, oh, I have a really good idea about this, or any tools like that?
Where somebody asked me for something. Well, actually, one came out of me and Dave Solomon teaching Windows Internals classes together, which I started to do in the late 90s, and we co-authored this book actually together. I've got a little picture of it here.
Oh, nice.
The little story on this one, Dave wrote this book called Inside Windows NT. And second edition after the Helen Custer famous Inside Windows NT that came out when NT did. And I looked at that book. I was going to do my own internals book, and I'm like, wow, he's just raised the bar so high. He had demo kind of samples and demos inside the text to illustrate concepts with tools that came in the NT resource kit. And I wanted to be a part of the next version of it. So I'm like, Dave, hey, how about letting me join as co-author? I can take some of the articles that I've written and incorporate those into the book, and then I can bring the Sysinternals tools in and add a whole lot of new experiments to the book. And there's some stuff that he had to negotiate with Microsoft that, related to some of the tools, because I'd pissed Microsoft off a little bit, and they're like, okay, fine, you can. The tools are on a CD on the book, but I started to teach Windows Internals with him too, even including going to Microsoft. But one of the things that we would do is experiments live in the class and on the screen. And the challenge was that you'd have to make the fonts super big, and there's some where you couldn't control. So it was really hard for people to see the demos a lot of times. So Dave had this tool that came with one of his pointers that on a laptop that will let you magnify stuff. And so we started to use that, and it was kind of clunky, like the hotkeys to magnify were clunky, and you couldn't do annotations very well in it. And so I'm like, after a couple of years, I'm like, this is obnoxious. I'm doing my own.
And you're talking about Zoom It.
Zoom It, yeah.
I use that thing religiously to this day. The other thing is that you were making these tools for free, but there was a moment in time where you decided there's got to be a way to monetize these things. And then there's a fun story on the way to Microsoft as well. Why don't you talk about that?
Well, so I was happy just writing these tools and making them free. Bryce had this idea for this tool that we ended up calling NT Recover. he's like, hey, what if we take one of the problems that we saw, even ourselves, in doing our stuff is you get the system into a state where it wouldn't boot. And like, how do you get data off that system that doesn't boot? How do you go fix it? And Bryce is like, what if we take the serial cable that we use for debugging and connect it between the two things and boot the dead machine off of floppy, and then have a program running on Windows NT that would mount that, have a driver that would make that remote disk look like it's a local disk, and then it would mount it, and then you could look at it, use all your favorite tools to recover data off it and fix it. And so we ended up writing that, and he's like, the recovery part's gold. We can sell that. So we decided, like, hey, let's start a company. And actually, I owe Bryce this basically because he's the one that went and got the business license. He set up the e-commerce site. This is 1996 as well. Yeah. And then he started copying floppies. He got floppy machine copiers, and then went to the shipping place, and he'd answer tech support. Meanwhile, I was working at IBM at the time. Yeah. I'd already gone to IBM, so I was doing this in my spare time. But that's how Winternals got off the ground. And NT Recover, just in the first month, we sold $1,000 of it. In the second month, it was like $5,000, and it just kind of took off. And we were advertising the tool on Sysinternals and making a free read version. This is a shareware idea that we made on Sysinternals. So a year into that, and I was making enough money on the side from my IBM job that I was like, I've always wanted a Ferrari. I'm going to go buy a Ferrari, and so that's
really cool. And I have stories of, because my dad is a doctor, right? He's retired, and back in the day, he put all his medical records on some machines, and I turned them on and broke them, right? And he's like, well, you got to get that back, son. If I would have had a tool like that, it would have been a lot easier to do that. So tell me about like the move into Microsoft. Did they just bring all the tools in with you, or what was all that like? Because now your job is very different, obviously.
Yeah. So 2006, the acquisition happened, and it was acquisition of both Sysinternals and Winternals. They're both independent legal entities. Sysinternals being free, Winternals being the commercial software company. We had 85 employees at the time. So acquisition of both and the technology of both. One of the things that I really was passionate about and was keeping Sysinternals going. Mm-hmm. In fact, the day the acquisition is announced, Microsoft put up a blog post. We put up a thing on Winternals and Sysinternals saying Microsoft's acquired it, and there was a mad rush of people to download. Everybody go download. Microsoft's going to kill this, and so our web server crashed. That's what they did at the time.
Yeah, back in the day.
Yeah, so we had to keep it up and running, and we're like, no, don't, calm down. It's not going anywhere. But the Winternals tools became part of Microsoft Desktop and Recovery Toolkit, MS Dart, and part of our backup tool too, so Data Protection Manager. The Sysinternals tools, I was basically left, me and Bryce, both joined Microsoft, to continue working on them. And so we just did that and continued working on them in the spare time. We worked in Windows as day jobs, but the first tool that I wrote with Bryce after coming is Process Monitor, mm-hmm. which is it's probably the most useful tool for troubleshooting. Yes. In fact, this is a slogan somebody came up with that Dave Solomon came up with it, actually, I think. We can't remember the quite origin of this, but when in doubt, before it was when in doubt, run FileMon and Regmon. Really, this was the combination of those two plus a whole lot more power. So that became T-shirts, and that became a thing. And we would say, when in doubt, I would get audiences to say in troubleshooting, a case of then explain talks, when in doubt, and run Procmon.
Before we get into like the current state of the tools and the future, by the time, and I really want to dig into this, by the time people are using these kinds of tools, some pretty serious things have happened, right? Do you have some interesting stories of customers using these things and the reasons why? You don't have to give us names and dates or anything, but I'd love to hear some of the interesting stories from customers.
Well, there's just hundreds of examples of users using the tools to solve problems. And one of the things that became a slogan for Sysinternals and Winternals was, "You saved my butt," or "You saved my,"
Yes.
And so we actually had Winternals ad campaign that was, save your butt, kind of thing. But that was, so there's just hundreds, and I would incorporate them into the Case Unexplained talks. But some of the most kind of funny ones were one of the tools that I wrote was the blue screen screensaver that would, like a screensaver, when it was your system was idle, would draw a very realistic blue screen. And then I took it a step further. I'm like, I'm going to make it look like it's rebooting your machine too, with the Windows logo and the scroll, the progress bar is, and then it would crash again. It looked like it crashed again. And I'd have people that would run this on production machine, and then somebody would come by and be like, oh, this machine's crashing. I'm going to reset it, and then take down their production machine. So not the intended effect. Then people use it to play pranks. And there's a tool, one of the most popular tools, PS Exec, part of the PS tools, that lets you run things remotely. It's actually much better than PowerShell remoting. It is like the way to do remote desktop administration. I'm just poking Jeffrey Snover there.
We should. We have to. It's part of every interview.
Yes, it is. But PS Exec is still incredibly popular. But what people would do with PS Exec and the blue screen screensaver is run it on somebody else's machine, and then they would freak out and think their machine was crashing.
Oh my goodness! Because back in the day, the machines were literally under people's desks, and if you push the button, like the web server would go down. Kind of thing. Yeah. That's funny. Any other interesting stories or things that people used your tools for that you were surprised about?
Well, lots of tools like these. A tool is a tool, and it doesn't have any inherent goodness or badness,
right,
but
of course.
People can take a tool and use it for good purposes or bad ones. PS Exec is a prime example of this, actually, because a lot of hackers get on corporate networks and then spread through it, and the way that they spread is taking advantage of PS Exec. So PS Exec, countless, and still even today, you'll see security analysis of malware and infiltration into a corporate network, and and then they use PS Exec to jump from one machine to the other. So that was it kind of surprised me, I guess. And I didn't kind of realize that it was going to be used that way, right. And then it was.
That's cool. Okay, so let's talk about now Sysinternals at Microsoft. There's a whole docs page with tons of different tools. One thing that I've always asked myself, and maybe you can answer this, maybe you can, is why aren't they part of Windows?
Yeah, that's a question that I get all the time, and I still see it on Twitter. It's like, why aren't these just built into Windows? One of the reasons that they're not built into Windows is Windows used to have a very slow ship cadence. And so that the rate of refresh on tools and bug fixes and feature additions, I didn't want to be constrained. So even, I was like, I need to keep these independent so that we can release them. And they go across lots of versions of Windows. In fact, the tools for a long time, up until probably 6 or 7 years ago, supported both Windows 95, no, maybe older than that, but Windows 95 as well as Windows NT. So it was the agility of the release that I didn't want impacted. But the other one is that the Windows bar is much higher than freeware toolbar.
Yes.
And it's like full support, for SLAs with customers and customer support, and a lot of machinery goes into supporting a tool that is part of Windows from a legal perspective and from customer promise perspective. And I didn't want to have these things slow down. I mean, obviously very popular with what we were doing, the kind of level of support and the kind of level of polish that we had on them, and I wanted to preserve that. So that's another reason that we kept them outside of being shipped in the box as Windows.
And that's interesting that you mentioned legal reasons, because if you're downloading these tools, you're taking some responsibility for what's going on, as opposed to, you have a EULA in Windows that promises and does certain things.
Yeah, and the EULA in Sysinternals is like, these are on, for your own use.
As is,
As is, yeah.
No merchantability. That's
Exactly.
the word that we always read in our software. Yeah. So another question, and maybe you can't answer this, but I'm going to ask it anyways. Why aren't these open sourced?
Another question that I get all the time. And on the Windows ones, one of the reasons that they're not open source is that a lot of them use undocumented APIs. So I mentioned, Regmon was one example up until it folded into Process Monitor, but Process Monitor also uses some undocumented APIs. And the reason not to make them open source is that effectively documents them. And once you document an API, you're also responsible for documentation and backward compatibility, and that would constrain in some ways the ability for the core of Windows to evolve, kind of inadvertently, right? If you don't do it deliberately, you're not going to be able to preserve those kinds of guarantees that customers expect out of documented APIs. So that's really the key reason. Now, some of them are tools that use fully documented APIs, and the reason I haven't open sourced them is that open sourcing actually takes some effort. Like if you're going to open source, you need to like embrace the spirit of open source, which is, I'm going to put this up. You can do pull requests on it. I'm going to look at your pull requests. I'm going to, so I was like, really, it was more of, don't want to again burden the tools with that, and also not be worried about the line of which ones are using non-documented APIs, which ones are, kind of thing. So that's the reason for that. Now on the Linux side, we've taken it's Linux, it's open source. So there's some new Linux tools. And for those, we're starting just with those being completely open source.
And I was going to ask you about Linux, because all the way at the beginning, you mentioned that you did some things in Linux-style systems. Are we doing things with Linux-style systems now?
What do you mean we doing things?
Like for example, are Sysinternals tools going to work on Linux?
Yeah. So yes, Linux used at Microsoft, in Azure, it's exploded.
Yeah.
In fact, there's more cores on running Linux. External cores running Linux than Windows cores in Azure. So hugely important for us to support Linux. And what I looked at is like a lot of these tools make sense on Linux. So one of the tools, the first one that we made a version for Linux, process dump, it's called Proctom. We said, hey, there's a good reason to have process dumping capability on Linux that uses triggers like process dump for Windows. And then you can control where the dumps go and the other capabilities that are part of that tool. And so we created Proctom for Linux. And Proctom for Windows is actually used inside of Azure's infrastructure. Proctom for Linux is going to be used in Azure's infrastructure. So it's kind of one of these kind of core utilities that make sense in both operating system environments. And then we're excited to announce here at this event the release of Sysmon, which is a security monitoring tool that I wrote back in 2014 when John Lambert, who works in our threat intelligence group, writing tools and tracking hunt bad actors, came and called me up and said, hey, I need to come over and talk to you about something. It's like we've got a bad actor that we've seen on our network, and we need it'd be nice if we had a tool that would let us better track exactly what they're doing. And here's what it needs to do: track processes, track files. They do this shredding thing where they drop a file, they use it, and then they delete it and they shred it by overriding it so that when we do forensics, we can't see what they ran. Like, it'd be cool if you could have the tool catch that. And I'm like, well, I've got a lot of that infrastructure already ready, in one of the tools, Process Monitor. So I could just start with that and probably have something for you pretty quickly. So 2 weeks later, I'm like, here's a tool that does what you wanted. And so he used it and found it effective. And then we said, hey, we should make this. Can I make this in Sysinternals tool? And we said yes. There's some capabilities that we'd like to be withheld from the public version for now, which are all now in the public version, like clipboard copy and this file shredding recovery. But that was Sysmon, and so that excited today to announce that Sysmon for Linux is out, which we've been talking about working on for a while. But it's, of course, a completely different implementation for Linux, but it has the same purpose. And one of the powerful aspects of Sysmon for Windows is its filtering capability that lets you say, I'm looking for this particular signature for malware. Let me write a configuration file that captures that. And that's something that there's no built-in tool in Windows or Linux to have that fine-grained filtering of what you want to capture with all the level of detail that you capture that is relevant to security analysis. And so that's built in with compatibility in the configuration file and the same kind of behavior as the Sysmon for Windows, now available for Linux.
So, future of Sysinternals. I mean, are you still writing? Are you literally going in there and writing stuff still?
Yeah, I do.
Future.
Not nearly as much as I did. For example, one of the most recent things, I'll add little things every now and then, but I added to Sysmon, what was the last thing I just added? It's hard for even me to remember. I added a feature to it just a few months ago. And it's.
I bet it was awesome.
It was really
it was the best
feature.
feature ever. You're not going to want to be without it.
I know. I remember what it was. So one of the hacker tools is to launch a process. It's called process. This technique is called process hollowing, where you launch a process like Notepad, and then the malware unloads Notepad and the Notepad executable from the process address space, and then loads in their malware. So when you look from the outside about what's happening, it's like Notepad's doing all this funky stuff, but it's not really Notepad. So I added a detection in process and Sysmon for detecting those techniques of process hollowing. And I did that a while ago. That's one of the most recent things. So I still do work on the tools. But now we've got a few other developers that are contributing to the tools, including people that are working like Mario and Kevin Sheldrake, Thomas Garnier, who work on the Linux side of things as well, which I've also participated in the design of those as well. So I do still, have an active role in what the tools are and where they're going and what we should prioritize, and then throw in features every now and then. So
nobody should rush and try to download them all because they're going away. It's still active and there's still going to be stuff happening.
Oh yeah, for sure. In fact, so now we've got actually a few devs that are full-time on Sysinternals. Up until now, it was first me and Bryce, and then we hired somebody to kind of manage the website kind of operations things, and then we hired somebody else to help work on the tools. So now we've got a few people that are just full-time job. Let's keep the tools fresh. We try to shoot for a release of tools every month of something. So yeah.
I'm a fan. I mean, I've been using Zoomit forever. I use the what was it? The Process Explorer,
Process Monitor,
that one to see which text text file is holding up everything.
Yeah, Process Explorer.
Process Explorer, and I enjoy them thoroughly. Like I said, I've literally used it today, and I've used it like almost every day since. This has been super cool. Anything else you'd like to add to finish up?
Well, one of the things, there's support you can get, like there's forums for Sysinternals, but one of the cool things is, and it's still a great reference, is this book that actually this is not the right version of it, but this book, this was the first book that I wrote with Aidan Marcuss.
They finally let you write the book, not like the other one, right?
That's right. Yeah, this one. And that book, which is in the second edition, is called Troubleshooting with the Sysinternals Tools with Aidan Marcuss, who's giving a talk here at the seminar, a couple talks at the seminar on a couple of the tools. Really is a fantastic, you really want to understand the tools and what to do with them, and it's got a bunch of case then explains. That is a great reference to help you get the most out of them.
And just from a pedagogical perspective, I wanted to use a $5 word here.
Yeah.
Using those tools gives you a really good sense of what's actually going on under the hood, which is super useful. And it's what got you excited about these things in the first place, right?
That's right. Yeah. No, I mean, they've had a huge impact on my life, obviously. Just the knowledge I've got on them, the enjoyment I've got out of I mean, I still today, I'll go visit a customer and they go to the EBC and a customer will come in and be like, this Sysinternals tools, man, those are so awesome. Or I used them 10 years ago and my career has been, so much better because of those tools. It's so rewarding to hear that.
All right, so here's a question that I've had. What makes a tool a Sysinternals tool? There's got to be some bar, right?
Yeah, well, one of the things that I believe from the start of, if I'm going to use a tool, I don't want to install it. I just want to use it. And so that was a principle from the very first tool is I can just copy it someplace and use it, which is kind of the Linux Unix philosophy. And I'd actually come from working a lot on Unix. The other one is that it shouldn't leave any stuff behind. They clean up after themselves and try to not to leave anything behind on your system. And a third one is, in general, this isn't 100% true. I didn't want to have to write manuals and documentation for them, and I wanted them to be very straightforward and kind of self-explanatory and intuitive to use. And so that's been another key goal of the tools is no manual required. You can run the tool and kind of figure out your way around it pretty quickly.
It's funny you should say that because I'm not even kidding. I have on Windows C:\util on my path, and I literally download the system and I just put them in there.
Yeah.
And then I just call it, right? Yeah. And that's actually pretty cool because I've seen that and I didn't know that was a philosophy. Okay.
Oh, by the way, speaking of that, that's another announcement for today. They're now in the Windows Store, so you can install them. They will go into your Start menu, and they will also be accessible through shortcuts from the command prompt. So they'll always be kept up to date. So that's another thing that we're doing today.
That's actually pretty useful because every once in a while I was like, I should probably change my util directory with the newest ones. So that's a really cool thing. Now, another question that I've had, because there's so many tools and I've seen a lot of them, sometimes I get a little overwhelmed myself. Which ones are the indispensable ones that people should try out?
Yeah, well, I think just going through the most popular ones will get you basically that list. Autoruns, which will show you what's configured to start and run on your system automatically. So if you want to go get off the crap that's popping up when you log in and figure out how to get rid of it because you still like the thing, but you don't like it popping up, or you're going after malware hunting, Autoruns. Process Explorer to understand what's actually running and find out who's got the who's got the open file. Process Monitor, so #1 tool for troubleshooting. Zoom It for, I use Zoom It myself to zoom in on text on my screen when it's too small. Yeah. And rather than having to change my fonts and DPI, I'll just zoom in. You can also get screen clips very quickly from it, like zoom in on something and do Control-S or Control-C, and you get.
I did not know that.
Yeah,
that's cool.
Little undocumented tip, or it's documented, but little tip there for you. So I'd say that those are the big ones. And then if you're working in security, Sysmon, which is a security monitoring tool, logging tool.
Well, awesome. Thank you so much for spending some time with us, Mark. And thank you so much for watching. Cis Internals is now 25 years old and hopefully many years to come. Thank you for watching, and we'll see you in a little bit.
Hi, my name is Mark Russinovich. Welcome to Sysinternals Tools Overview. I started Sysinternals back in 1996 with my friend from graduate school, Bryce Cogswell. Back then it was called Internals. A few years later we renamed it to Sysinternals. But the goals of the site have always remained the same from the start, which is to make available tools and information to help you understand the way Windows works or troubleshoot Windows when it's not working like it should. The principles around the tools have been that they're single file, that they're intuitive to use, and that they don't leave behind anything on your system after you've finished using them. While the tools from the start originally supported Windows 95, Windows 98, Windows NT, and today support 32-bit versions of Windows, 64-bit versions of Windows, ARM 64-bit versions of Windows, single file means that you can download one tool and run it across all these various systems. It will dynamically detect what it's on, and for example, if you're on 64-bit Windows, the 32-bit main executable will extract 64-bit versions, launch them, and then when they're terminated, clean them up. When you go to the Sysinternals website, you can see the downloads links over here on the left side. Clicking on that will take you to a full list of the tools. And at the top you can see that there's various suite bundles. This is the main suite bundle, which includes the 32-bit and 64-bit versions of the tools. You can see that there's a Nano server bundle for Windows Server version Nano server, and then there's another one that just has the ARM 64 versions of the tools. Clicking on the suite will open up the suite's contents, and you can see that there's close to 80 versions of the tools. Now, one of the tools that's my favorite is the one that I've been using to highlight and zoom, and it's called Zoom It. Zoom It lets you zoom in statically, as you can see. You can see that I'm able to draw freeform, draw shapes like arrows, like squares, and even like circles. You can change colors by typing various keys to represent different color, like G for green, Y for yellow, B for blue. You can even make the screen completely black and then draw freeform there. You can type T and then type. And it also has live zoom capability, so you can actually zoom in and move around and interact with the screen while you're zooming. Now, in this talk, besides just giving you an overview of the site like I just did, I'm also going to highlight some of the most popular tools and tell you just a little bit about them and why you might be interested in them. Following this session, there's additional deep dive talks by experts on each one of these tools. And let's start by looking at Process Explorer. A lot of people have called Process Explorer Task Manager on steroids. So if you've used Task Manager to identify what's consuming a lot of CPU or disk or memory, Process Explorer does that, but much more, and gives you much more detailed information about those processes on your system. One of the most common uses of Process Explorer is to find out what has a particular file opened. And for example, if you're trying to delete it, you might be wondering, how do I delete that file? And that you can do that through a file search capability. Here, if I go to Find, File Handler DLL, and type in Zoom It, for example, you'll see that zoomit.exe is in use, that file, by the Zoom It process. And you can see that the system process has a bunch of handles open to it, as well as the 132 process has opens to the threads open in Zoom It. Now, when you open Process Explorer, you see this convenient process tree, which shows you parent-child relationship between processes if the parents and children both are still in existence. When you hover the tooltip over a process, you can see its command line, you can see its path, you can see services for service hosting processes like this service host. And then there's columns that will show you CPU usage, memory usage, both virtual and physical, description of the image, the company name, but you can add dozens of additional columns that show you very conveniently additional information about those processes. all of this information, like DPI awareness, what process protections it has, whether control flow guard is active, are available also in the process properties. When you go click on the process properties and look at the image tab, for example, you'll see there, again, the command line current version, things like what user context it's running in. Here are the control flow guard and other process protection settings. And then you can see additional tabs that show you information about performance. You can see graphical views of the performance, private bytes, I/O, CPU usage, disk and network counts, CPU, GPU graphs if it's using the GPU, what services are active in it. It's threads, information about which threads, where they're starting, their thread IDs, how much CPU they're consuming, any TCP/IP endpoints they've got open, the security context of that the process is running in, which is represented in something called the token, its environment variables, and then what strings it has in the image in memory or on disk. And this can help you identify the purpose of a process that you might be unfamiliar with. The other things Process Explorer can do is show you information about the handles and DLLs that are loaded into a process. If you go and show the lower pane, you can see here is the handle view, which shows you the operating system resources that the process currently has open, files, registry keys, and so on. If you click on modules, you'll see mapped files as well as DLLs. DLLs being those executables that it's running code from, and mapped files being files that, like these natural language string files, that it might be loading to represent different resources. And then finally in the threads tab, you see additional information about the threads, much more than you saw in the threads tab in the process properties. Additionally, you can see these convenient system views at the top, which will show you the most active by CPU consumption. It'll show you the system commit usage, the physical memory usage over time, and a summary view here of all of those stats across the system. And this is just dipping our toes into the things that Process Explorer can show you. One of the most powerful tools in the suite, and really when you ask me which is the one that I've used the most besides Zoomit, it is Process Monitor. Process Monitor is a tool that captures file, registry, networking, and profile information. It shows you full thread stacks. It shows you it has flexible non-destructive filtering. It can capture literally millions of events. It shows you a process tree of the running processes that have existed at all times during the execution of Process Monitor, including ones that have terminated. And you can also capture all of the activity through an entire Windows lifecycle, from very early in the boot process all the way through shutdown. It is so powerful at showing you what's going on in the system that it is the #1 tool when it comes to troubleshooting. In fact, it solves many cases where you think Process Monitor is not going to show us the answer, but it turns out that it does. Me and Dave Solomon, when we were working on troubleshooting in our classes that we teach, the predecessor to Process Monitor was called FileMon and RegMon, and we similarly found that those tools solving so many problems that we unexpectedly that we came up with the phrase, when in doubt, run FileMon and RegMon. Of course, when Process Monitor, me and Bryce delivered that shortly after we joined Microsoft, the catchphrase turned into, when in doubt, run Procmon. So think, something's happening on my system, what's going on, let's run Procmon. If I go take a look at Process Monitor here, I've got an active trace that I'd captured just a little while ago as I was preparing for this session. And you can see here in the display the time of day, the process name, the process ID, the operation. Here's a create file, the path of that particular operation. And if it's a file operation, this would be a file system path, the result, and then additional attributes here. You can see the desired access, the disposition, whether it was an open or creating new file. You can see the attributes, the share mode, and so on. Lots of information about exactly what's happening. Like I mentioned, if you go to the event properties and go to stack, you can actually see the full stack that led to that operation, which can give you information about what exactly is executing this operation and why it is. And you can see it's resolving symbols here to show us the stack, and the symbol names like path is directory is a call that's being executed here to see if this path is actually a directory or not. The reason that I've got this open and this trace captured here is I was downloading the Sysinternals suite, and here you can see the full suite of tools like I showed you earlier. And I was copying it over my tools directory, which you can see right here, which is where I got my local copy of the tools. I ran into this error here as I was doing it. The action can't be completed because the folder or file is open in another program. Close the folder or file and try again. Well, first, this message is a little bit vague. What is keeping this file or folder open and why? And if I do this again, you can see there it was partway through the copy operation, but this error just continues. And I had no idea at the time I ran into this what was causing it. So I ran Process Monitor, typed in an additional filter just for the tools directory. You can see here, path begins with ctools include, which includes only references to the tools directory. And now I can immediately see what was going on. These can't delete errors correspond to the error message in that dialog box. And what Explorer was trying to do was to delete zoomit.exe. As we saw earlier in the Process Explorer 5 dialog, zoomit.exe in the tools directory is actually opened by Zoomit itself because I launched it from there, and so that's why I couldn't delete it. So here I can immediately understand what that source of that error, kind of vague error message was. And if I wanted to get past this, now I could just simply exit zoomit.exe and that error would go away and I'd be able to finish copying. So again, Process Monitor to the rescue here on solving a kind of unexplained situation. The next tool we'll take a look at is called Autoruns. It is one of the most popular tools on the site because it gives you information about what is configured to start and run automatically on your system in far richer detail and comprehensiveness than any other tool. It knows of literally hundreds of different locations. You can see here, as I've got it running, that it categorizes things into various groups. The Everything tab shows you everything that it's aware of that is configured on this system to automatically launch, whether things that are built into Windows or added by third-party software on this machine. But then you can drill down into specific categories, like what's configured to launch when you log onto the system, what's configured when Explorer launches, like Explorer context menu handlers that you can see here, scheduled tasks, services that are scheduled to run, drivers, codecs, boot execute, print drivers, what's configured to launch as part of WinLogon, the logon manager, interactive logon manager, and much more. Then you can see when we click on something down here at the bottom, you can see additional information about it, like the publisher, the size, the time that it was built, and the path to it. One of the key characteristics of Autoruns is helping you identify what's been added to your system after base Windows components run, and for that you can go to the options and do things like hiding Microsoft entries or hiding Windows entries here that will just let you focus on what third-party software is configured. It will also, in the case of something that is foreign to you, like what is this doing on my machine, let you go search for it online or submit it to VirusTotal, a free service run by Google that has files that are submitted run through dozens of antivirus tools. I've done that earlier with zoomit.exe, and if I open this report up, you can see that no security vendors flagged this file as malicious. There were 67 virus scanners run on the zoomit.exe executable, whether it was at the time that I submitted that or previously by somebody else, and no hits were found. And so this is a good way to help you identify, is something malicious or not on my machine. Next tool I'll talk about is called Proctom. This one's a little more esoteric, really for people that are trying to understand what is crashing on their system and perhaps in a position through use of debuggers to understand why, or to be able to submit a crash dump to a publisher of that software to help them understand what happened. So Process Explorer and Task Manager both have ways that you can create a dump of a specific process, but I created Proctom back when I ran into situations where I would have something that would spike the CPU on my machine, and I wanted to understand what was causing the CPU spike. It also, one of the challenges that Microsoft support ran into is Outlook having hangs. So capturing a dump when a process hanged. And so this called for a tool that you could run, capture a dump of a particular process on demand, but also be able to set triggers that would give you the ability to say, only capture a dump if the CPU goes above this limit, capture a dump if there's been an exception, capture a dump on a termination. And Proctom has those kinds of triggers built into it, plus much, much more. Further, you can install Proctom as a postmortem debugger, meaning you can register it on the system so it captures a dump of any process that has an exception on the machine. And that lets you get exact kind of dump information that you want, because Proctom supports various sizes of dumps, from a full dump, which is the entire memory and context of the process, down to mini dumps, which are just small summaries basically of just the core context information and the memory pages that are referenced from that core context. You can also leverage dump extensions to create custom dumps that, for example, Microsoft Support does, to capture the most relevant parts of, for example, a piece of software that has large amounts of memory in use, and some of that has interesting information for dump analysis and some of it doesn't. Let me just give you a quick example of Proctom in action. If I go and go to my tools directory and say proc dump -C20 to say if this process is consuming more than 20% of the CPU, then create a dump of this process CPU stress, which I've got running right here, and put it in the temp directory. So now we see if that process executes more than 20% of the system CPU for a threshold of more than 10 seconds, then it will create a dump. And here's the format of the dump name, which is all of this is completely configurable. I've got it paused right here, but when I activate these threads, CPU stress being another tool from Cis Internals, just to show you to generate CPU activity on your machine, you can see now Proctom is seeing that it's above the threshold, and here we go, 10 seconds of above 20%, and now we've got our dump listed. So a great tool to help you troubleshoot your own processes and diagnose them if you're a software developer, or to be able to capture dumps that you can submit to the software publisher. Now the next tool that I'm going to show you isn't actually a tool, it's a collection of tools. It's the PS Tools suite of tools. And the reason it's called PS Tools is because the first tool that I wrote as part of this back in the late 1990s was PS List, a tool that would show you much more than the tools that were built into Windows about which processes were running from the command prompt. Of course, I had a Process Explorer that would show you information about the running processes in graphical mode, but if you needed to very quickly from a command line see what processes are running, which ones are consuming CPU, PS List was the tool for that. Further, PS List would let you look at the processes running on remote systems as well. So from a single system, you could see across your network all of this, the process activity across them from a simple command line tool. And the reason it was called PS List is because it would list processes, and like the PS tool in Unix, which I'd used in grad school. So as I started to add tools to this with the same capabilities, single file executable, able to run both locally as well as across remote systems, and having the same kind of way of being able to authenticate with username and password to remote systems, thus began this collection of tools with all the PS prefix to identify them as having those characteristics. And you can see that there's now over a dozen of these tools in this collection, the newest one being PS Ping. But the most popular tool by far is PS Exec. PS Exec lets you remotely execute programs remotely, interactively, as yourself or in alternate credentials, and lets you do things like troubleshoot what's going on and basically remotify any local command. Like ipconfig by itself, you can't run against a local machine, remote machine, but using PS Exec, you can. And command prompt doesn't let you natively run against a local machine, but with PS Exec, you can. So if I type Mr. Surface 4, which is my laptop machine next to me, and I say I want to run command.exe, PS Exec is going to start a remote service on that machine. It's going to create an interactive session by connecting the standard in and standard out named pipes that command prompts have. And that will let me interact with that machine remotely. So here in a few seconds, when the connection is finished, I'll be able to type hostname and see that sure enough, I'm interacting with the command prompt that is actually not this machine, which when I exit this PS exec and type hostname, we'll see that the hostname is actually Mr. Game and not Mr. Surface. The final tool that I'll drill into is called Sysmon. What Sysmon does is monitor and report key system activity that are related to security relevant events into the Windows Event Log. It's a tool that I created back in 2014 when John Lambert, who's in our Microsoft Threat Intelligence group, came to me, said that we had malicious activity on the Microsoft corporate network. The attacker was dropping files and then shredding them so that we couldn't see what tools they were using. And he wanted both additional information about which processes were running on as the attacker was moving around, which wasn't available in the built-in Windows event logging at the time, but he also wanted to be able to capture those tools so that we could see what those tools were made of. So I wrote Sysmon. Thomas Garnier joined me shortly after the first version and added additional capabilities like capturing clipboard activity. Now, these special features of capturing shredded, deleted files and clipboard activity were something that we didn't introduce into the public version until just the last few years, in fact, just within the last year. But they were in the internal version and ones that we would share with key partners. Now it's all of the capabilities are in the public version of Sysmon, and Sysmon has become one of the most popular system security monitoring tools available for Windows. It's literally installed on hundreds of thousands or millions of machines and corporations across the world, and including at some of the most security sensitive organizations like government agencies. One of the key capabilities, value propositions of Sysmon is that it gives you very detailed information about things like process create, network connections, but it also has very rich filtering capabilities. So you can create monitoring rules that will only have Sysmon collect information about what is interesting or relevant to you and ignore the rest. And this is what has made Sysmon so unique and so popular. One of the things that you are also available now is a whole ecosystem has been created around Sysmon of people sharing information about how to configure and deploy Sysmon, including a couple out there that have created community configuration files that have hundreds of rules in them that are even linked with MITRE detections, so that you can just simply take those configurations, deploy them on your corporate network, know that those have been validated and are running at massive scale, and also designed to capture very security relevant information. I'll just quickly show you Sysmon in action here, because Sysmon, when we run it, you can see that I've already got it running here. And the config file, I just ran it from the command prompt and just ran it to install without any specific configuration. In that mode, it already collects some interesting information like process termination and process creation with detailed information, as well as a few other types of information. So if I go into the Sysmon event log here, you can see process create, process terminated rules, and for process create, if I double click, you can see here's Sysmon, which I just ran just a second ago with the command line, the current directory, the user, the logon with the terminal session ID, as well as the hashes that I've configured to capture here, the SHA-256 hash, which is the default hash that's collected, plus the parent process and child process. One of the unique features of Sysmon here that is a little bit different than the built-in Windows monitoring is that every process is given a unique identifier, the process GUID that Sysmon assigns. And so this lets you, even if
processes have the same name to identify the direct linkage for instance of process to instance of process. So I can see that the parent process GUID of this Sysmon instance is that process GUID. I can search the log and find where that process was created to know exactly what that was. And here you can see the full list of information that's captured by Sysmon, from process create all the way to file deletes, that you can just log file deletion, or process tampering, which is process hollowing detections, and much more. Now, that basically has been a focus of the Sysinternals tools on Windows. Me and Bryce actually wrote some Sysinternals tools for Linux back in the early 2000s. FileMon, which was a tool we originally created for Windows, we made a version of it for Linux. But because of the way the Linux kernel evolved, it became hard for FileMon to keep up without being completely broken. And so we eventually deprecated that tool and removed it. So there were no Sysinternals tools for Linux for a long time, up until the last few years. And over the last few years, we've introduced 3 Sysinternals tools for Linux, all versions of the Windows tools, but designed to work on Linux. The first one is Proctom there at the bottom. It creates the same kind of principles, creates process dumps based off trigger information. Then Process Monitor, which is something new we're releasing, Process Monitor activity for Linux, capturing system calls, letting you do the same kind of filtering you can for Windows, but aimed at console interfaces. And then finally, Sysmon for Linux. And the benefit of Sysmon for Linux is that, unlike the other tools that are available for auditing system events, system security related events on Linux, Sysmon for Linux has the same exact schema and configuration file and log file schema as Sysmon for Windows. And that means that if you, like many, have both Linux and Windows in your environment, you can use the same tool with the same kind of design for schema and capture, like process creation capture, across all your different operating systems. So that brings me to the conclusion of the overview. Hope you found it interesting. Hope you found the tools compelling and want to explore some of the other tools of the 80 in the suite. But again, stay tuned for follow-on expert deep dive sessions into those tools that I highlighted as I went through the talk. I showed you kind of a real-world Case the Unexplained. Case the Unexplained is a series of talks that I ran on Tech Ed and then Ignite sessions, as well as other conference sessions where I would collect, people would send me troubleshooting cases like the one I just showed you, and with log files and screenshots to demonstrate how they solve those tools with Sysinternals. I've got the collection of those Case the Unexplained talks. If you go to sysinternals.com, you can go find those sessions. Everyone has different cases with different ways that people use the tools to troubleshoot. So it's a great way to become an expert in using the tools to troubleshoot. And if you want to go a little bit deeper, the official book on Sysinternals tools is called Troubleshooting with the Sysinternals Tools, which is not only about troubleshooting, but about the tools themselves. And it's authoritative. It was authored by myself, as well as a friend, Aidan Marcuss. It covers every tool, every feature, with tips on how to use the tools, and has full chapters on the tools that we covered and more, and has 45 example troubleshooting cases in text form. Some of those captured from my blog, some of those brand new. So that's also a great, rich source of information. And finally, I'm excited to announce, instead of having to always keep up with sysinternals.com to stay fresh with the tools, we've introduced Sysinternals into the Windows App Store. So now you can go and download the Sysinternals app, and what that will do is automatically keep the tools fresh, install them into a directory with shortcuts so you can run them from everywhere automatically from your path, as well as puts them in the start menu so that you can access them from there. So with that, enjoy the rest of the day. Thank you for participating in the Sysinternals 25th anniversary.
I first met Mark in person at the WinDev conference back in 1999 in Santa Clara. We were both speaking at this conference, and I had heard about the evil Dr. Russinovich and the hacking he had been doing on Windows and the tools he had been writing in articles to expose supposedly evil schemes by Microsoft, and certainly considered him somebody I would keep at a long arm's length. So he was giving a talk. I decided to stand in the back of the room, hoping nobody would see me. And I remember interrupting him a couple of times to correct him because he didn't get it all right. I had the source code, he didn't. Well, we decided to meet for lunch, so we sat at a round table. I remember feeling nervous sitting next to him, like I was going to be contaminated by such a nefarious character. And we talked a bit, but I felt it was a tense discussion, like a meeting between the US and Russia during the Cold War.
Process Explorer is probably the most well-known tool in the Sysinternals suite. Hi, my name is Pavel, and I want to do a quick deep dive into Process Explorer, see what it can do, and most importantly, how to understand and what the information it provides actually means. So I'm a developer, trainer, and author, and apparently a speaker as well. And in fact, I've been part of the Sysinternals team for the last 9 months or so. So if you see any new bugs appearing in recent tools, it's probably on me. And I've been writing a few books recently. You can find all that information online if you're interested. So normally people think of Process Explorer as a super task manager, because Task Manager also shows process information, but Process Explorer shows much more information, much greater detail than Task Manager ever could. In this screenshot, you see the current Process Explorer on the left and some enhancement I'll show you today on the right. So what is Process Explorer? Its main feature is to show dynamic information about the running system. This is mostly about processes. I mean, it is called Process Explorer for a reason. So it shows information about processes and whatever is contained within these processes, such as threads, modules, handles, TCP connections, and lots of other stuff. It also shows information about kernel objects while we view handles in the particular process of interest, and I'll show you that as well. It has some global information about the system, such as CPU usage, memory, I/O networking, and so on. Some of the information is textual. In fact, most of it is textual, but there are some graphs that allow you to see some things as they pass through time, as they change through time, such as CPU utilization, memory utilization, and so on a system-wide basis or on a process basis. There's also a set of operations you can do on processes. Well, first you can kill processes, but then there are other stuff you can do with processes, such as suspend them and view other information about threads and also perhaps suspend them as well. You can also close handles, which might come in handy from time to time. One thing that Process Explorer also does very well is allow us to search for interesting objects across the system. So this could be files, it could be other named objects such as mutexes, semaphores, and other types of objects Windows supports. That's kind of the basic overview, but really what we want to do is look at Process Explorer itself. So let's go to Process Explorer. Here is Process Explorer. When you open Process Explorer for the first time, it looks something like this. You have a tree-like view of processes, and then for each process, you get these various columns. So these are just some of the columns that are available. If you want more, you can right-click, go to Select Columns, and then you get a very big list of columns divided to various categories to make it a bit easier to find what you're looking for. Now, first consider this tree-like data structure. What does that really mean? If I go ahead and double-click one of these processes, you can see in the Image tab, it talks about the parent of the process. So the parent of this particular process is Svc Host with the process ID 1444, which happens to be exactly this one as it's shown here in the tree. Here's 1444. Of course, we can move columns around if we want them to be in a different location. So it talks about and shows the parent of that process. Now, for some processes, it seems that they're completely left justified. It seems like they don't have a parent. So let's take a quick example, such as a WinLogon here. So if I go ahead and double-click WinLogon, apparently WinLogon doesn't have a parent process. It's a non-existent process which has the ID 1216. So in fact, it was the process ID of that process, but no other information is available for that process because that process is now gone. And the parent process ID is stored in the child process ID. Now, it's important to understand in Windows that there is no parent-child relationship in terms of any kind of dependency, which means that if process A creates process B and process A dies, process B is completely unaffected. So we have this process which doesn't have a parent. What about this ID, however? Can a new process be created that has the same ID? The answer is yes. Process IDs are not unique throughout the lifetime of a system. They're only unique as long as the process is alive. However, Process Explorer is not confused. if it has another process called 1216 that has since been created, Process Explorer also compares the start time of that process. If the start time is after our current process, then surely it can't be the parent process for that process. And so Process doesn't get confused and will still show non-existent process for that particular case. So the question who created who is sometimes interesting to understand how things get created. And that's what the tree-like structure shows us. If you want to sort in a normal way, you can simply go ahead and sort from A to Z or Z to A. The other thing that is fairly obvious in Process Explorer are these colors. So these colors not for making Process Explorer pretty, although that might be a good reason for having them, but for each color there is some significant aspect that is part of the process in question. So let's see a few examples. One of them is this yellowish process. So yellowish processes are for .NET. It means that that particular process is hosting the CLR, the .NET runtime. And when you double-click or look at the properties for that process, you'll find that there are two tabs here. One of them is called .NET Assemblies, which shows all the .NET assemblies loaded into the application domains of this process. And there is a .NET Performance tab here that shows some performance counters that you can find in usually using other tools such as Performance Monitor. And this is the .NET CLR memory category, but there are other categories here which are also related to .NET. So for other types of processes that don't host the CLR, you will not see these tabs in the properties. These are contextual tabs. They only exist for .NET processes. Let's take another color as an example. We have this pinkish color. So this pinkish color is for services. And just like with .NET, there is a special tab in that particular case called services. So you see that in this particular example, I've double-clicked an executable, which is hosting a single service right here. And in fact, it is implemented as an executable, which normal processes have to be implemented in this way. However, if you're familiar with Windows, you probably are very familiar with this thing called Svc Host. And this Svc Host thing is a generic host for services that Windows uses for most of its services coming out of the box. If I double-click any one of those, we'll see the Services tab existing in that properties, but then you'll notice that the actual implementation is for services in a DLL, which makes sense because we have a generic executable, a generic process to host services, so the particular detail of the specific service has to be coming from somewhere else, which is that DLL. And in today's systems, you'll find that most services are actually hosted in their own process. You can see there are many Svc host instances here flying around. There's one perhaps that is a bit different, and it's hosting multiple services. One of them is very important. That would be the DCOM launch service, which is critical to Windows, in fact, and Windows can't really function without it. It has some very important responsibilities. So the ability to host multiple services in a single process, this is the thing that is using these DLLs for. So the ability to have services implemented as DLLs allows us to load multiple services into the same process. And previously, before Windows 10 version 17.03, there was some form of segregation where you had multiple services in a single process to conserve processes, to conserve system resources. However, starting with version 17.03 of Windows 10, if the system has at least 3.5 gigabytes of RAM, for standard systems, that's probably not an issue, but could be an issue for IoT devices, so Windows Phone and such small devices, then most services get their own process. And this is for robustness and stability. So if one service crashes, it brings down its process, and the only service that is affected is that process. On the other hand, if you have multiple services in the same process, one service causes some exception, then the entire process shuts down, causing all the other services, which are not to blame, to crash as well. So pink processes are about services that are hosted in that particular executable, that particular process, to be more precise. Then we have these cyan color. So this cyan color is mostly used for UWP processes. So for example, I have a calculator here running, and if you go ahead and look out for calculator, you'll see that it has this cyan color. So these are applications that are usually using the Windows, they're using the Windows runtime, and they have some extra management on top of them. For example, if I go ahead and minimize calculator now, you'll notice that the process becomes suspended and changes color to the suspended color if I enable that color, which means that all the threads in the process have now been suspended and nothing can happen in calculator. Once I restore calculator, its process goes back to life and it can continue doing its calculator thing. And so most cyan processes you'll find are these kinds of processes, but it's not precise. So for example, if you go ahead and look at Explorer, you'll find that Explorer also has this cyan color. Does that mean that Windows Explorer can be minimized, causing it to be suspended? The answer is no. And the cyan color really is about hosting the Windows runtime, using Windows runtime APIs. Behind the scenes, there's a function, is immersive process, which is the one that's actually being used by Process Explorer to determine whether to color a process with cyan color. And so Explorer is definitely not a UWP application, but it is using Windows runtime APIs, and that's why we get that color. You also find many processes of type runtime broker, which are helpers, UWP processes that allow them to do certain operations which they cannot do on their own. And that's because UWP processes run inside something called an application container or app container. You can see that in the integrity column here. And container means, among other things, very low power, in the sense that you can't access resources or objects that have medium integrity level or higher in any invasive way. App container really means low integrity level. So integrity level is another very interesting aspect of Windows security, but unfortunately we don't really have time to discuss that. So we have these colors, and let me talk about maybe one or two other colors. So we have this particular color. This is a color called fuchsia. This is the default here for protected processes. So protected processes can't be accessed invasively from user mode, regardless of the user's powers. So even if the user is administrator or has any crazy privileges, it doesn't matter. You can only get very shallow information about a protected process, whether that's protected with the classic protection from Vista or the protected process Lite, which is the enhanced protection, or more, I would say, flexible protection module from Windows 8.1 and later. You can figure that out using that protection column. So if I want, I can even sort here by protection. You can see the various protection values that you have here. And these are based on the signer and the level of the signer. So some signers are more powerful than others. And there's these two modules, the classic protected model and the protected light module. And so this is the fuchsia color. And by default, you will not see that color because it is not enabled by default. So you can go to Options, Configure Colors, and then enable that color if you wish. So I've enabled most of the colors except for jobs. We can do that as well. And in that case, we'll find that many processes get colored with that brownish color. These are processes that are part of a job. And just like with other cases, when I double click one of these, we get another contextual tab here, which is the job tab. And the job tab shows all the processes that are part of that job. In this particular case, I've selected one of the instances of WMI per VSE, which is the WMI worker process or worker executable, which we have multiple instances running. And we can see that there are some limitations on that job. So the purpose of a job in general is to manage a set of processes as a unit, providing some form of limitations or limits to these processes. So you can see here some limits so that WMI service request and operations that are going to happen because of that request will not consume too much system resources. So for instance, the job cannot consume more than 1 GB of memory. Number of processors cannot go beyond 32. So Process Explorer shows you the limits that a job has. So again, this tab is contextual and will not appear for processes that are not part of the job. So these are some of the colors you can find in Process Explorer, and as we've seen, you can configure those to see them or not see them based on your preferences. And so other than that, the important part that we see in Process Explorer is that it has a lower pane. So you can show that lower pane by clicking some toolbar button or using the Control-L shortcut. And once you do that, what you get is a pane here at the bottom that now contains 3 tabs for handlers, modules, and threads. This is a new feature in Process Explorer. Previously, you had only modules or handlers, and you could switch between them. But now we have some tabs here which you can switch between and show threads also, not just modules or handlers. So any process you select here, doesn't really matter which process that is, you get the view changing based on your selection. And of course, you can sort any one of these columns in terms of threads here, and even perform some operations such as looking at the call stack, the module, maybe even terminate the process, and the thread, and suspend the thread as well if this is what you want. And of course, we can switch to the modules view to see all the modules that are currently loaded into the process address space, seeing the name, description, path, and the base address and image base. So the base address is where the DLL is actually loaded, and image base is where the DLL would have liked to be loaded. And if these things are not the same, it means that the DLL has gone through a relocation process. And this is also marked in this yellowish color right here. So you can see here that the numbers here are different, which means that this particular DLL had to be relocated because its preferred address was already taken. So you can see here a list of properties for DLLs. And of course, this is just a partial list of columns. You can right-click, you get to the DLL columns. You can select other columns you would like to see, because by default, you actually don't see some of the columns I'm showing here. And then we have the Handles tab. So the Handles tab is about showing us all the handlers that are part of the handle table of the process. We know that every process has its own handle table, and these handles point to various kernel objects. In fact, most of the functionality in Windows is provided through kernel objects. So if you want to do stuff, for example, you want to open a file, you have to obtain a handle to a file object that represents the connection to the file you would like to talk to. And without a handle, you can't really talk to the file. And so these handles are just numbers that are indices into some tables which are in kernel space, but you can see the numbers right here. And you need to remember that every handle table is private to the process. So if I have a handle here to some registry key with the value 78x, I can't just pass along that number to a different process. That doesn't make any sense, because the other process has its own handle table where 78 points to a completely different object, or maybe to nothing. And so it's important to realize handles are private to a process. So again, when you just start up Process Explorer for the first time, you just see the type and name columns, but you can right-click as always and show more columns for looking at handles. So you can see the handle value, and the first handle which is valid has the value of 4. 0 is never a valid handle value. You can see the type of object, and Windows has many types of objects, some of which we understand very well because we can use them and we see them all the time, such as processes and threads and registry keys and files and so on. Some of them perhaps not so much because they're more internal, and some of them in fact are completely undocumented. Here we can see the name of the object, and this is kind of a tricky column. It's not really the name of the object in all cases, but it is some form of name that makes it easy for us to understand some more details about the object that is pointed to by that handle. I'll say a few more things about that in just a moment. Then we have the access mask here. The access mask is a set of bits indicating what is the power of that handle. So I might have multiple handles to the same object. It doesn't mean that all these handles are the same. Each handle has its own power. And so that power is represented by the access mask. For instance, this registry key has the access mask to 0019, and in order to understand what that really means, we have to go to the Windows SDK documentation to figure out what each of these bits mean, or we can just look at the decoded access column, which tries to interpret that value in a human readable way. So essentially, we can see here that this handle can do read operations from that registry key, which means that if it tries to do something like a write operation for that key, that would fail with access denied. So not all handles are born the same. Same goes for every other handle you see here. Then we have the object address. The object address is where the real object is in kernel space. We can see here that the address is a very big number, which is what we expect on a 64-bit system, because the kernel space starts at the upper 128 terabytes of address space. So this is somewhere inside that address space. What can we do with that address? Well, onto itself, nothing. From user mode, that information is practically useless. But if you're doing some kernel debugging or have a kernel debugger available to you, you can actually use that address to gain more information about the object by looking at it through the kernel debugger. So for instance, if I go ahead and double click one of these handles, what we see here are properties for the object. So notice the properties are for the object, not for the handle. The properties of the handle itself is just represented here by this line, which means that if I double click two handles that point to the same object, I'll see the exact same information, because this is about the object, not about the handle. And so you can see the name of the object, the type, some description. Here's the address again where the object is in kernel space. We can see here number of handles that are open to this object, currently just one. Then we have reference sets, which is kind of weird because it's supposed to give us the total reference count of an object. Kernel objects are managed with the reference count, and only when the reference count goes to 0, only then the object is destroyed. However, if you look at Windows 8.1 and later, the reference count seems like something that doesn't really make much sense. I mean, could there really be 65,000 something kernel clients holding pointers to the object or something like that? It is unlikely. So in fact, this number combines a usage for the handle. So to actually see what it really means, Process Explorer in this case falls short. There's no way to get that information from user mode very easily. We can go to a kernel debugger just for fun and just use the object command with that address. And then we get the information about the fact this is a registry key, and you see the same pointer count or something a bit different because it is based on usage. You can click that, and then you get the true ref command, which will show you the real reference count for this object. So it takes a couple of seconds to figure this thing out, but eventually we'll get the actual result. So this is something we can't get from Process Explorer because it doesn't have the full view of what is going on in the kernel. However, in the meantime, one thing I did wanted to show in terms of modules before I forget, if I go to something like CSRSS, which is a protected process, notice we see the list of modules and DLLs inside this process. If you've used previous versions of Process Explorer, you wouldn't see that information. But now we do, and that's because we use the Process Explorer driver, assuming you're running Process Explorer with admin privileges, to open a powerful handle to the process and circumvent the limitation we get from user mode, not being able to access invasively protected processes, but now we can because we leverage the power of the kernel. So now all protected processes do have a list of modules, and the list is not empty as you might find in previous versions of Process Explorer. So back to handles, here's the actual pointer count, that would be 1. So the reference count in 1 is 1, which means this is the only handle and the pointer to the object. So back to handles here, one of the perhaps trickiest parts here is understanding the role of name. In fact, when you think of the list that you see here, is this the entire list of handles in the process? So not really. This only shows named object as far as Process Explorer is concerned. To see the true list of all the handles in the process, we have to go to the View menu and select here Show Unnamed Handles and Mappings. Once we do that, we see that the list is greatly extended. Now we have many more handles than we previously saw in the process, and that is truly the full handle table for the process. You notice that handle number 4 does really exist, and number 8 exists as well. These are just for objects that don't have names, which are just normal objects just like anyone else. They just don't have names, which is fine. A name is definitely not mandatory, and some object types, in fact, can't have names anyway. So this is fine. Previously, we've seen 34 as the first handle, but in fact, it is not the first handle. So back to named objects only, I want to focus on names a little bit. So these names are not really that trivial to understand. Some objects are truly named. They do have names. For example, sections have names, events have names, semaphores and mutexes have names, and these are true names, which means we can open the object by name using an appropriate API. However, some objects here that seem to have a name don't really have a name. So let's look at some examples. One of them is process. So processes don't really have names. Processes have IDs. However, Process Explorer shows us a name for the process because it is just useful to see that information, but it is not a true name. This is a process ID, of course, but it shows us as a named object. Same goes for threads. Threads also don't really have names. They have IDs. So you can see here that this particular handle points to a thread inside the Explorer itself, and that would be the thread ID, which of course is something that might be useful information for us, but it is not a named object. So you might be familiar with the feature introduced in Windows 10 where you can actually give a description to a thread using the set thread description API. And so you can associate a string with the thread, but it is not a thread name. It doesn't have to be unique, and there's no way to look up a thread based on that description. In fact, it is mostly used for debugging purposes. Visual Studio can show the description of a thread, for example, that could help you identify interesting threads in your application. So these are not named objects. Another type of object which is not named are keys. Registry keys don't really have names. It might seem very odd. What do you mean you don't have a name? Here is a name, but no, this is just a path pointing to registry key. The object itself doesn't really have a name. And the most confusing aspect is definitely files. So file objects really don't have names, which seems really, really odd. I mean, what do you mean they don't have names? Isn't that a name for a file or a directory? So yes, this is a path, but it is not the name of the file object. This is not really about files. File objects are a way to contact or to communicate with devices, where files in the file system are just one particular case. And to prove that, there is another tool I would like to briefly show you, which is WinObj. WinObj is another Sysinternals tool that shows us all the named objects in the system, all the truly named objects in the system. And they are managed in this kind of hierarchical manner. Let me run this with admin privileges so that we can see everything. And so you can see various types of objects here, such as events and semaphores. In fact, under sessions 1 and base named objects, you'll find all the named objects created by processes in session 1. So I dare you to find here a file. You won't find a file here. You won't find a registry key. You can search, but you won't find anything like that. This is kind of a proof that file objects don't really have names. You can't open a file object by name. You can open a file, which is a different thing, and you'll get a new file object representing your connection to that file or device. But this is not about names at all. So file objects don't really have names, but Process Explorer shows file objects here as though they have names because it is, of course, very convenient and very nice thing to see that I can know which handle points to which actual file. So this is definitely convenient, but it's not really a name for the object. Another feature of Process Explorer is the ability to find. You can use Control-Shift-F to open this dialog for performing search, and it says handle or DLL substring, but really it means any kind of named objects as names as Process Explorer sees them. So if I write something, part of a name or whatever that may be, we might be able to find something. So I can do something, maybe Explorer. So Explorer could be related to DLL names, could be related to mutexes that have the name, the string Explorer somewhere there. So you can see everything that has this Explorer thing searched throughout the system. And then, of course, we can we can cancel the search if we have too much items, too many items anyway. In any case, we can click any one of these entries and we jump to exact the process and the handle that this thing represents. So the search is really about named objects, including naming as far as Process Explorer is concerned, which means file names as well. So one very classic case where this is useful is when you're trying to delete some file and that file fails to delete because someone is holding that file. And so Process Explorer can allow you with that search option to quickly locate the processes or process that has an open handle to the file, which is why you can't delete the file. And then you can just close the handle if you wish, or terminate the process, and then you'll be able to delete that file. And so if you right-click here, you can actually close the handle. Normally, I don't recommend it, but if you know what you're doing, you can do that. You can close the handle behind the process back. So this is, again, something that you can't do very easily. So the close handle API that some of you are probably familiar with can only close the handle in the current process. But in fact, there is a way to close in a handle in another process using the duplicate handle API with the flag duplicate close source. And that's kind of the way Process Explorer does it in order to actually close the handle in a different process. Usually, this is very dangerous in a sense because the other process would get its handle kind of gone away without it even noticing. So this is Process Explorer, some of the aspects of Process Explorer. Of course, there are many other things I could talk about, but we only have 30 minutes and my 30 minutes are almost up. Thank you very much. I hope you enjoy Process Explorer. I hope you enjoy the new features, and hopefully we'll continue to evolve Process Explorer even further and other tools as well, of course. Oh, one last thing. If you're like me and you like something darker than these bright colors, you can use Options, Theme, and switch Process Explorer to a dark theme, which is, of course, a new feature in Process Explorer that I hope you like.
Some months later, Mark approached me to propose working together on the next edition of the Windows Internals book. So I had finished the second edition, which covered NT4. Mark was working on a competing book. Mine came out, and he thought it would be more practical to collaborate on the next edition, which was going to be updated for Windows 2000. And I remember when he contacted me, he said, "Dave, you built the house. I just want to add a room on." But he certainly did more than adding a room. He moved in, he redecorated, took some walls down, and we had a great collaborative effort working on the book together in long sessions. Coincidentally, at the time, we lived about 15, 20 minutes apart in Connecticut, and we would alternate working at each other's homes. Often we had a race to find the answers to questions. Me with the source code and Mark with his Sysinternals tools, digging under the cover through his reverse engineering approach. And sadly, often he was faster than finding the answer than I was with the source code.
Hey everyone, my name is Sami Laiho. I'm a Microsoft MVP from Finland. It's really difficult for me to believe that it's actually been 5 years since I hosted the Cis Internals 20th birthday party. And now having the privilege of Mark inviting me to speak, and not just about anything, but about Process Monitor, which is the second most downloaded tool on the Cis Internals toolkit. I personally teach Cis Internals and Windows internals all around the world, and I speak at different conferences, and I have been doing this for more than half my life, for about 20 to 25 years. I'm a Microsoft MCT and MVP and all sorts of stuff. I love showing this slide always, because when I introduced myself at Ignite, they gave me a presentation deck that had one line that said, please fill in all your certificates. And I just piled them on the floor and I thought, what am I going to write here? But then I came up with a great idea, and I just actually put them on a kitchen scale and I weighed them. So I have 2.6 pounds of certifications. But heading into the topic today, I have heard so many great speakers talk about Sysinternals tools for the past 25 years or so. I mean, when I started my career, those were the tools that got me started. And I had the privilege of going to a Windows internals class once, which was taught by David Solomon and Mark Russinovich, whom both you have or will hear today. And David always said that if something breaks in Windows, run Regmon and Filemon. Those two tools later on ended up being what nowadays is known as Process Monitor. Process Monitor itself is a tool that shows you main categories of file, registry, network, process, and performance measurements, and it outputs a lot of stuff. And easily, when I teach Process Monitor, I have like two different skill sets. I teach people how to press the buttons, and then I have another course where I have to teach people of what you actually see with it, because those are two different skills. Process Monitor can easily output hundreds of thousands of lines in a trace file, and your job of deciphering what that actually means is a totally different skill set. What I'm aiming today to do is give you some tips and tricks on how you might make your life a little bit easier with the tool. After downloading the tool itself, the tool has a 32 and a 64-bit version. And depending on your platform, you choose the correct one, or depending on the trace file that you're looking at, you choose the correct version. When you start Process Monitor itself doesn't actually require admin rights if you're just looking at a trace. But if you are tracing yourself, then there is a requirement for admin rights, because you have to install a device driver. And this device driver is a filter driver. So with the command fltmc, you can actually see that. And here on the screen, you can see that Process Monitor filter. This that you see on the screen is a list of different filter drivers, and you can see the altitude value next to them. And this altitude value, it's kind of a nosedive. So input-output packets go through these filter drivers, starting from the highest altitude and going down as a nosedive towards the lowest altitude. Sometimes the packets actually don't hit Process Monitor early enough or late enough, which means that these can actually be changed in the registry. So there is a way of changing these values in the registry. There's no real GUI way of doing this, but it is doable. And I have to do it occasionally when I have to trace, for example, what a Windows Defender or another kind of security solution, for example, is doing. Talking about filtering, there are a few things that I felt like life-altering when I saw Aidan Marcuss show one of these as the first thing on a session he did at Ignite. And it really changed the way I'm using the Process Monitor. The problem with Process Monitor is that it is really difficult to keep Process Monitor running for extended periods of time, because it outputs so much data. Let's dig into a demo and see how we can actually keep Process Monitor running. Here on this demo environment, I have a Windows 10 machine, and I intentionally have an older version, Windows 7, next to me, but we'll keep that for now. And I'm actually going to demonstrate quite a lot of different things about Process Monitor at the same time. So first, let's just go and start off Procmon. When Procmon loads, you can see that the numbers down below start increasing very heavily. So we have already 15,000 events being captured, and that number there is increasing heavily. Now, the problem is that if you look at the default settings of the backing files where this trace data is actually stored, then these are stored in the page file. Now, at the end of the day, if you fill your page file, by default, Windows will allow you to just increase the page file size, basically as long as you run out of space on your C drive. And we all know that Windows doesn't really work if you run out of space on your C drive. If you keep it here, leave it running over the night, the problem is you are going to face a computer that you need to reboot in the morning. So let's just get out of there. For now, I am just going to stop the trace itself. And you can do that by pressing Ctrl-E as well. So there's a shortcut for that. I'm also going to clean out the log file for now. So that'll be Ctrl-X if you want to use the keyboard. I'll start this off by showing you a problem I had on my own computer. I once had my own computer in a situation where I suddenly couldn't access the internet anymore. And when I was trying to access the internet and I couldn't do it, I went troubleshooting all around the place, and then I realized that I actually had suddenly a proxy setting that had appeared from nothing or from nowhere. It was set to 127.0.0.1, which is the loopback address of Windows. Now, for a security person like me, this feels horrible because this sounds like maybe someone's hacked me because they're trying to route all the traffic back to the computer itself. I just removed the setting and everything worked fine. Then, about 2 weeks later, the same problem appeared. I knew what to look for. I went to take out the setting. I could get online again, all good. Maybe a week after that, same thing happens again. Now, the problem is very common for me as a troubleshooter, which is that I'm never there when something happens. Customer calls me and says, Sami, can you come and check out this issue? I'll go there, check out the issue, and they can never reproduce it while I'm there. This was kind of the same thing. I was never there when it actually happened. But if I leave process monitor running, I can't run it for 2 weeks. Let's first figure out where this setting actually is so that we can monitor and report when something goes and alters it. First things first, let's open up Process Monitor, and I am going to set a filter whenever I'm trying to find a registry setting and I don't know where it is, then I will use Process Monitor, and I always start with a certain filter. And that filter is operation is rec set value. Many people, when they use Process Monitor to figure out what an application does, investigate how an application works, they start to monitor for that certain process. But I don't do it that way, but instead I always look for all changes in the registry while I was tracing. That okay. And then I am going to start tracing. And then I'm going to go for the setting that I want to change. And I'm going to change it to something else. So I'll just change this to 127.0.0.2. Hit OK. We can go back to Process Monitor, stop tracing, so we don't have that much stuff there. And if you have any kind of a string in your setting, it might be easy to just go and press Ctrl-F and try to find the string. So we've made a string which was 127.0.0.2. And we'll just hit Find Next. And here we can see that setting. So it set something like proxy server. Remember that the most important thing many times for Process Monitor is actually hiding here. So the detail column hides the actual values. And here you can see the value. There's another thing to Process Monitor, which is called quick filtering. So if I right click on a column, I can just choose to include only this. Now we see only entries that somehow affect this proxy server. So first go on and enable the tracing. We're going to go back to the setting that I had. So we're going to open up that again. And then we'll go and open connections, LAN settings. We're going to set this again. Hit OK. Hit OK. Go back to Proctom, and we can see that we can now see when something changes that setting. Great. But the problem lies down here. We only have one event showing, but we have more than 200,000 events already in the log, which means that I can't keep this here for 2 weeks because I'll fill the page file. Proctom by default only filters the view, not the content that actually goes into the log, but only what you see on the screen, which is great so that we can later on get things back on the screen without filtering them out forever. But for being able to do this for the next 2 weeks, let's try something else. I'm going to stop tracing again. I'm going to clean the log. And now what I'm going to choose is I'm actually going to go and I will say that we have the filter, and we're going to choose drop filtered events. Now, when I start to capture again, you can see that there's no events in the log. And what happens instead is we are actually filtering before we put things into the log. If I go and change my setting again, and we'll go and just change that now to, let's say, back to 127001. Okay, okay. Go back to Proctom, only one event, and showing all one events. Now you can easily keep Proctom running for the next 2 weeks to just capture the problem. And if someone's interested, it was just a faulty version of OneDrive, which for some reason thought that because I had Visual Studio installed, it started rerouting the traffic back for debugging purposes, and OneDrive, a cloud service that sets the proxy server to be the loopback address, you could call that really counterproductive. But anyway, so that's just a good tip. I'm gonna clean this out and I'll just turn on our filtering to normal. Now, getting to the next topic. When you want to script process monitor, the first thing is that you should note that when you just run proctom /? And you can see a huge amount of different kinds of command line parameters. If you actually look very carefully, you can see a cool new thing there that was introduced some time ago, which kind of can give you the same benefits as the demonstration before. And there is a flight recording mode. So you can have it to use a circular log and just not spend that much of your hard disk space. Does not remove the need for the previous demo, but it is a good background, all the time black box kind of flight recorder. Anyway, I have a very common question that I get from my customers, which is how do I troubleshoot someone else's computer because Proctom does not support remote monitoring? Well, that's true. Proctom does not support remote monitoring. I can't use Proctom on my machine and ask it to record another computer. But what I can do is take another Sysinternals tool. There are people who would tell me that you should do this in PowerShell. I want to be hip and cool as well, which means that I do have demonstrations now on Sysinternals tools, but after this, I'll show you examples on how you can do that with PowerShell as well. But now let's just dig in and try how we can actually make Process Monitor record on a remote computer. So now that we are concentrating on Sysinternals, I will use Exec. And with Exec, I am going to start Process Monitor on the computer next to me. I intentionally have a different operating system version here so that we can learn a few other things about Process Monitor's abilities. So I'm going to use Exec, and I'm going to say that Exec, please run with system rights without waiting for the process to end. Those are those parameters. The computer is called student25, and I'm going to say, please run Proctom. Now, if Proctom is already on the machine, that's fine. If it's not there yet, you have to add another parameter here for C, which means copy. And that means that it'll copy the binary first over to the other computer. So we use Proctom. Now, the most commonly used parameter of all Sysinternals tools probably is the accept EULA, which means that we don't know if the other computer has already accepted that EULA, which means that we're going to have to do that when we use these in batch files, for example. So Process Monitor, and now we need to get that file to ourselves somehow. So I'm going to set a packing file, and I'm just going to put it in the ctemp folder called process.pml, which is the default format. I don't want it to whisper anything to the user interface. On that other machine, let's pretend that we have an issue with Notepad here. So this person here will now, after we told them that please reproduce the problem, they're going to just start Notepad and do something with it. I'm just going to generate some traffic to the trace file. So I'll just open some dialogues here and do something like this. And after they have reproduced the problem, then it's time for us to stop monitoring. Now, if you go and kill Process Monitor, it'll corrupt the PML file, which means you have to gracefully stop it. So with Exec, we are going to tell Proctom now, instead of backing up anything, we are going to just say terminate. And now, after terminating Process Monitor on that machine, then we can just do copy student 25 C drive and procsys.pml. I'll copy it to my own temp folder, and then we can use Procmon. Let's just open up Procmon, and I'll just reset the filter, and I'll say open. I am going to open that file from the C temp folder. And now a few other things. First of all, if you go for tools and choose system details, we can verify that this is actually coming from the other computer. It's not Windows 10 like my computer here, but Windows 7 Service Pack 1 like you can see on the right side. Also, another great tool inside of Process Monitor is the process tree. The process tree shows you almost like a snapshot of Process Explorer and shows you what was running during that lifetime of that trace file. And there we can, for example, see that many of these files were running all the time, or processes were running all the time, but then we can also see that we have this notepad here. You can just use this, right-click and add process to include filter, and then you will have a process monitor trace taken remotely from another computer concentrating on the problematic application that we had. When I have an issue with my customers and I need to troubleshoot something, I always tell them that there are two things I need at least. The other one is a process monitor trace, and the other one is a network trace. Process monitor trace, you can start with Exec running Procmon on the other machine. You can do the same thing for NetSH trace. Since Windows 7, network tracing is built into the operating system even without installing Wireshark or Message Analyzer or anything like that. Like I promised, here is the hip and cool PowerShell example as well. So nothing prevents you from doing this over PowerShell, but I think it was just a really neat thing to do that with Exec because it is Cis Internals' birthday party anyway. If you want to know what happens during a boot in Windows, the problem of course is that Procmon is not running by default, but we can set Process Monitor to be a critical boot driver as well. And setting that allows us to capture also, for example, load times of different drivers and to see a good picture of how the boot process actually behaves. So now in Process Monitor, if you go and choose options, there is an option here called Enable Boot Logging. And we can also generate profiling events every second or every 100 milliseconds, which means that it takes like a snapshot of the most common measurements of your performance, like CPU, memory, and stuff like that. But let's just do this without. Then you have to go out of Process Monitor, and then you just go and reboot the machine. So now here we have the ready log to look at, but this is so disappointing because I was just bragging that we can use Process Monitor to see how the boot times are, and we can see how the boot drivers work and the load orders and try to find big gaps in the load times and stuff like that. But actually we can't see anything. I mean, it all starts here with the subsystem manager and there's nothing before it. And this is another important thing that you have to learn, which is that by default, Process Monitor has a very dramatic filter set on it. And if you look at the filter here, you can see that there's a lot of exclusions here. There's a few things here to point out. And for example, here, you can see the reason why you can't use Process Monitor to troubleshoot Process Explorer without touching the filter. Also, if you have someone who still insists that it is a great idea to move your page file from a disk to another, and you have to prove them whether the page file is even used or not, if you're trying to monitor for access to the page file, well, same thing here. Page file access is not shown. There's two options. You could go and just remove all of this, but it's even easier if you just go for filter and choose enable advanced output. This will take out the filter. And now you can see that we have loaded the Process Monitor sys file here, and then you can see all the drivers that are loaded after it. And that's a way to actually capture a boot trace in Procmon. One more thing, which is very common to all of the Sysinternals tools, and that is that by default it shows you a huge amount of information, sometimes maybe a little bit of an overload of information, but if you really want to see more information, you can do that. Now, the binaries that we are, or the processes that we're tracing with the tools for Sysinternals, when the processes load binary into the operating system, well, the binary operating on the computer doesn't really have to know any friendly names for functions, for example. They just need to know addresses where to jump to when something happens. And that means that if you go and use Process Monitor for looking at the stacks of a certain thread, for example, it will only show you addresses by default. We can decipher those, especially when we're talking about Microsoft binaries. We can use what's known as a public symbol server, and we can download symbol files. And those symbol files contain information of how to decipher those numbers or those hex addresses into actually human readable function names, for example. This is a two-part thing that you need to do. First of all, we have to have a debugger that supports downloading symbols. The default debugger that is in the C Windows System 32 folder cannot do that, but if you install the SDK, you can find a debugger that is capable of downloading those symbol files. And then the other part is that we have to understand where to download those symbol files for. There are two ways of setting this. You can set this in the Process Monitor options, but then you would have to set it in the Process Explorer options as well, which means that if you want to do this for all Sysinternals tools, and at the same time most of the debugging tools as well, you can also use a system variable. And that system variable you can see here down on the screen. So _nt _symbol _path, pointing to srv asterisk, then the local cache folder, and then star or asterisk, and then the download location for the Microsoft's public symbol server. Now, this is Microsoft stuff, so if you have your own code, you have your own symbol files, you can dump them to the local cache folder as well, or point to a server. This can point to multiple locations as well, just divided by or separated by the asterisk sign. But let's see that in action as well. So now that you're looking at a trace file, and if you go and right click on anything here and choose properties, or you can just click on the stack there already, but you can get there from here as well. And you can see that we have these things running on the computer, but you can see that we have these hex values here. And these hex values, I really don't know what they are because they're just the addresses inside of code. They are sadly not like Visual Basic script lines, which would be super easy to decipher, but at least we can make some sense of these by doing a few changes. First of all, you have to have the symbol file set. This one you can do from the system properties, and we'll just go for advanced environment variables, and here you can see the _nt _symbol _path pointing to this value. And now I have set that already. Now, if we go for Process Monitor and go for options and configure symbols, you can see that that is filled from that variable, but the debugger here will not do. So we'll have to change this to the SDK one that I've installed on the machine already. So that'll live in Program Files x86 and Windows Kits 10, debuggers, and x64. And then just hit open. That's it. You do have the possibility of even pointing at your source code files if you would really want to see the location inside of the source code, but we'll just hit OK here. Now, if we go and choose properties, you can see down there it says loading symbol module per module. It's starting to download, and you can see that we have these numbers gradually changing into text before your eyes. So that'll give you at least a little bit more information on the stacks of the process that you're looking at, and that'll help you out in building more accurate Google searches or building more accurate pointers of where to search for the solution. And I hope that some of these tips will help you out as much as they have helped me during my career. I have had the pleasure of a few times sitting in an airplane where someone next to me is listening to what I'm trying to do and then just looks at me and says, "Why didn't you use Proctom?" And I try to remind myself of that. I have a t-shirt, and the t-shirt always reminds me to just keep calm, use Proctom. And if you have anything that you need for Sysinternals or Windows internals in general, you can always reach me on Twitter. My Twitter handle is @Samilaiho. It has been a privilege, and I hope you enjoy the rest of the show. Thank you so much.
I used to use FileMon and Regmon before they were combined into the Proctom tool, often in troubleshooting both application and systems issues at a client site that I was doing some volunteer consulting for, and had many, many case studies, several of which made their way into the early editions of the Case of the Unexplained talk that Mark would give at TechEd. I don't remember who coined the phrase, but we would often say to each other, when in doubt, run FileMon and Regmon. We used to say that to each other a lot. And there were so many cases where there were errors that you could never, ever, ever trace to the root cause without using these monitoring tools. So those were really, truly lifesavers.
Hi everyone, my name is Thomas Garnier. I'm the co-creator of Sysmon and a security architect for Azure. Today I would like to talk about Sysmon, the origin of Sysmon, what it is, how you can use it, and discuss some hunting you can do with the latest events we added. Back in 2014, when an incident happened and we're trying to figure out what was going on, we were really chasing the attackers. We were trying to figure out what was their entry point, how they make it to the system, how they moved in the system, what kind of access do they have, which data they got access to. And the tools that were available on Windows at the time were pretty limited. Process creation event didn't have any command line included into it. You didn't have a lot of information about DLL being loaded, network connection, or any of the techniques attackers would use. Often, the best thing you could do was take a forensic snapshot of the machine, do offline analysis of it, and that will take hours. It will give you very limited information about what was going on, and it was not ideal. And you were really chasing things happening, not really having a clear picture of what was going on. To provide you an example with that, it was process creation event, which is the 4688 event on Windows, didn't used to have the command line. So what you would see is query, net, you would see a Svc host on the wrong path, it clearly looked like suspicious. You see ping, net, copy, but you didn't know really what happened. What you wanted to see was the full command line so that you could basically see that you had reconnaissance being done, the credentials were dumped, and there was lateral movement happening. So you could figure out exactly, okay, the attackers went on this machine, they used this malware, they used these techniques, and they moved to another machine, and you kind of define then the access the attackers had, but it was very hard to do so. So what we wanted to do was to move from chasing attackers to hunting them. And what we really needed was like Sysinternals Proctom as a service, which later became Sysmon. So we wanted to see process creation, DLL loading, and the ability to see different techniques the attackers were using. And we knew that a tool was faster to adapt than the operating system could ever adapt. We also knew that you needed a way to scale the event and do analysis effectively outside, which was pretty hard to do before. There was also a sense of like you need to improve Windows, like the baseline for process creation events, security events, system event had to be good enough so we could figure out things if the tool was not there. Also, if we were to build a tool, which we thought was the way forward, we knew that we might need to change Windows so the tool will get better. And so that was also useful for us to do that so that all the tools that people would use could benefit from improvement into the operating system. And so that's kind of why we created Sysmon. So let's go over an overview of Sysmon, what it does, and how you can use it. So Sysmon is a free tool that is available to download on Sysinternals. It's a service running in the background. It's a service and a driver. They run in the background. They collect information about their operating system and they send it to the Windows Event Log so they can be forwarded off the machine. The goal is to be able to do both logging a lot of what's happening in the operating system and be able to see attacks and anomaly of what's going on. For example, we collect the hash of processes so that you can see that a certain process has been seen only a very limited set of machines, or you can see the same malware being used in different places. There's a configuration that allows you to define exactly what you want to collect or not collect. And we designed the events that are saved and can be moved across the machine. We designed them so that they are easy to analyze. A good example for that is that usually when you have events, you have a process identifier. And that process identifier is not unique. It's only true on the OS at the moment where you took that event, when you built that event. And so if you wanted to look to an event and then cross-reference it, you had to take that event, the process ID for that event, and you had to go backward in time to find which process was on that machine with that identifier at that time. So instead, for Sysmon, what we did is we create a process GUID, a unique identifier, which is unique across all the machines on your environment. And so now the search is just a key value pair. So you see a process GUID and then you search that process GUID in the past, in the future, anywhere. It's just you only have one with that process GUID. Sysmon was created by Mark Russinovich and myself, with contribution for a whole bunch of people at Microsoft helping to improve the tool. Here's the high-level architecture of Sysmon. You have an executable, which is an installer. You launch that, it will install it on your machine. It will install a driver and a service. Both the driver and the service collect information about the operating system, and all the events are sent to the service, where there'll be a process correlation, there'll be filtering. And so once the events are filtered, they are saved into the Windows Event Logs for collection. The service also monitors if the configuration changed, so it can reload it and stay up to date without having to restart the service or the driver. Sysmon has a lot of different command lines that are very easy to use. You can install it with -i-accept EULA. You don't have to set the configuration. By default, it will just save the process that are being created, but the configuration will give you way more option, and I'll go into some example and show you how you can use it. You can also update the current configuration, as I said, like you don't have to restore the service or the driver, it will pick up the new configuration automatically. You can dump the current configuration, so if you only use -c, you will see the current configuration being used. You can both dump the schema for the configuration, so if you want to learn about new events, that's a way to do it through this or the documentation we provide. You can install the manifest for the event, which is useful for you if you took events from Sysmon from a machine and you want to read them on another machine. You have to install the manifest to do that well. And of course, you can install it pretty easily with -u. So one of the main features of Sysmon is event filtering. That's what allows you to scale in and out how many events you can collect or you want to collect. And the way it works is that you have a configuration file with inclusion or exclusion rules. The rule system will take the exclusion rules to see if it needs to exclude an event, and it will go through any inclusion rule as needed, so that you can basically define, I want to collect this, I want to exclude this, I want to include that or not. If you have an exclude rule, then everything else will be included, but you can have both of those rules at the same time. Sysmon is clever enough to understand when it doesn't need to listen to the sources of events. So if you exclude all the events for a specific event type, then Sysmon won't listen to any of the sources, so it doesn't use any of the CPU or the memory for the operating system. We also support a long list of different filters you can apply. I put the list there, and we keep improving it, trying to make it very useful, as easy as possible to use and useful. I provide an example of a configuration here where on this configuration, we decided we're going to collect the hashes for images for SHA-1 and 256. And when driver load event happens, if that driver is signed, the signature is valid, and the signature likely contains Microsoft Windows, we're going to discard these events. Any other events from driver load will be logged, but those ones will be discarded. That allows you basically to define, I don't care about loading of Microsoft Windows drivers, but I care about anything else. And so that allows you to define how you can scale your environment based on the nodes you see in your environment. You can tweak that. The configuration also allows you to create rule groups. The rule groups are useful for two things. The first one is it allows you to change how the fields are checked for a match for exclusion and inclusion. By default, we do an AND on all the fields. So all the fields have to match for that filter to work. But you can change that to see if any of the field matches, then that will be matched for the inclusion. So example here I have is create remote thread, where I set up a rule group of group relation OR. So that means that if the source image is CSRSS, or if the source image is WinLogon, then I'm going to exclude that event. The other reason like rule groups are useful is that you can attach a name to it, and that name will be embedded within the event. So the example I have here is for credential dumping. I set a rule group for credential dumping, and if it matches, then the event that will be generated, the process access event, will have a rule name field with credential dumping. When you collect that event, you can basically know that that's linked to that specific rule that was matched. That's very useful when you're doing hunting and you're trying to pinpoint very specific techniques, so you don't have to remember why you set up that event in the first place. The rule name helps you for that. You can also add that name to any field that matched that can be a source of help, and we have some configuration in the community that doing that instead. Here's the list of all the events we support right now, 26 of them. We keep growing that list every time we find there's something useful that we can collect and filter. I think last time we made a presentation about Sysmon, we had about 18. Now we added WMI support, we added DNS query, we added file delete, archive or logged, clipboard monitoring, and process tampering, which is detecting things like process overlay. And later in the presentation, I'm going to show you some example of how you can use some of those events for hunting, what kind of things you should look for. Now I would like to talk about some of the amazing community contributions that we have that could be useful for you. I want to go over 2 examples, and then I will give you a list of others that are very useful and helpful. So the first one I want to go through is the Sysmon config by Swift. That's a good starting point if you want to learn about Sysmon and if you want to build your own configuration, reducing noise of things that are not really interesting to collect. I'll put the link there if you take a closer look. I also put an example that shows you how the configuration is structured. So usually there's always like a large comment that explains what is the event, what you can learn about the techniques that are related to that event. And often what I like is that there are a lot of comments about why something was included or excluded, so you really understand how the configuration was built and why. I think it's one of the great configuration you can use to getting started if you don't know how your environment behave. And you can tweak it based on what you need. Another amazing configuration is the Sysmon modular by Olaf. It takes a kind of different approach to how you build a configuration. It has default and a verbose configuration if you care about that. But it does 2 things really well. It's a very modular, so you can build your own configuration based on your need. And it ties every configuration choices to the Meyer attack framework. So depending on your environment, depending on your risk, you can choose to include something or not. And that's a good way to see as well the coverage you'll have with that configuration. And if you look at the GitHub repo for that configuration, you can see all the files, and each one basically has a special include, exclude for different reasons. So if you look at the CDN network for DNS query, it has a list of all the CDN query names that you want to exclude and the reasons why you would like to exclude them, which is very useful in an environment where you're going to see a lot of DNS queries and there's a lot you might not care about. So here I put a list of guides, configuration, and signatures available for Sysmon. And we're very grateful for all the people that helps understand the different events, how you can deploy Sysmon, how you can analyze the events across Sysmon and other themes. So it's something that documentation can never really fully cover, and we're very grateful that everybody is helping Sysmon to be used better. So thank you, everybody. So now that you have installed Sysmon, you set up the configuration, you maybe use some of the community configuration or guides, you need to collect those events. I'm going to go through 2 examples of that. One of them is Splunk. So for Splunk, you can use the universal forwarder. I put 2 links to it, the official link for Splunk that links to the universal forwarder for downloading, and also a link to Olaf's GitHub repo who forked some of the previous scripts that were available that can be useful as a starting point. But you can set that up and to basically gather all the Sysmon events to your Splunk instance. And on your Splunk instance, you can install this Sysmon add-on that is now supported by Splunk so that it will correctly parse the events and allow you to query them faster. We also advise you that you exclude the Splunk binaries from being analyzed. And I added some of the rules you could use for that so that those events are not forwarded to Splunk and you don't get additional noise. Another way you can collect as well the events for analysis is Sentinel. So Sentinel support the analytics and the parsing for query of Sysmon events. The way you would do that is you install the Azure monitoring agent. You configure that agent to take the Sysmon event out. And then on your Sentinel instance, you install the Azure Sentinel Information Model, or ASIM, that will allow to automatically parse those events so it can be queried like any process creation event on Sentinel through the different views. And I put 2 different approaches you can do that for the views. You can use the Sysmon view that shows you the process, or you can use the generic process information source to see that as well. Now I would like to make an announcement about a partnership that we're doing with VirusTotal. So VirusTotal is this online portal where the community shares malware samples and IOCs in general about threats. And it's a very useful tool if you want to learn more about a family of malware, variants, and how detection is doing in that space. For example, you can see all the AV results and some of the behavior in general from that malware. The partnership is that we are working with VirusTotal so that the Sysinternals metadata are included within the behavior analysis of VirusTotal. And the Sysmon metadata will be available soon. What it means is that when Windows malware is uploaded to VirusTotal, we'll launch in Azure a near real-time analysis of that sample. And all the metadata will be summarized and sent back for everybody to use. We think it will be very valuable for the community to be able to have access to that information. And we think it will drastically improve the response time from any of the security product that can very quickly see the similarities of behavior and allow them to tweak their detection much faster. So we're very happy with that partnership. Let me give you an example of how it will look like. So that's still work in progress, but those are basically screenshots of how it will look like. In the behavior tab, you'll have the Microsoft Sysinternal, the Sysmon information, and that will include things like network communication and different file systems, like which file were deleted, which file were dropped on the machine, which registry keys were set for persistence. And you have a lot of information about process created, terminated, and the process tree. So you can basically see how attackers the malware is trying to stay on the machine, what kind of traces they will leave, which is very useful. We're very happy with this partnership. Now let's go over a couple of events and some of the latest Sysmon events and see how they can be used for hunting. And let's start with DNS query event. So the DNS query event allows you to see which process doing which DNS query. Sometimes you can see that on your environment, depending of the log access you have, you see this machine or this part of the network is doing this kind of DNS query. It's very useful to see on the machine which process is doing it. And you want to see those DNS query because it allows you to identify different malware behavior. You can identify miners, you can identify connection to a C2, you can see a connection as a Tor client to the Tor network. And a machine does a lot of DNS queries, so we advise you to look at the community configuration that I talked about before so that you can reduce the noise to start with. Sentinel also provide you on the GitHub repo a list of miners, hosts, and Tor proxies as well, which is very useful to start with. So the DNS query event looks like this. And I took an example of a miner. And so you can see that the query name is a known miner host, so you know that process is likely to do mining. The image is explorer.exe, which is strange because that's part of the Windows operating system. And if we do that correlation I talked about before, if you take the process GUID of that DNS query and you search it for the process creation event, you can see the Explorer instance that did that DNS query. And there's something strange with it because you can see that the command line doesn't look like the typical Explorer command line. He has those weird algorithm, and you can even see the miner DNS basically host name on the command line, which is very odd. So that transitions well into the other event I want to talk about, which is process tampering. Process tampering tries to detect techniques that are used to hide a process, such as process hollowing. Those techniques, they are used to make a process look legitimate, but swap the code underneath it so that it will do something else. They were built to evade things like EDR or existing tools on the system so that the event and the signal you get is incorrect. Olaf had a very good blog post about this that shows basically the Sysmon process tampering events and how they can be useful and can be configured. So we had in the previous with the miner, in previous slide with the miner, we had the process creation event with that strange command line. And if you were to look at Process Explorer, you could see that this process looks legitimate. The command line is strange, but the image loaded in it are all Microsoft sign. The process looks normal. And that's where the process tampering event can be useful. So if you take the process GUID again and you correlate it with the process tampering event, you can see that we created an event that said that the image was replaced. That allows you to see that something strange is going on in the system. That can be very useful when you're hunting attackers. The last event I would like to talk about is about WMI and how it can be used for persistence. So if you're not familiar with WMI, WMI is a database on Windows that allows you to learn more about the operating system and have events that happen for when different things happen in general. WMI can also be useful persistence for an attacker, persistence on a file or persistence as we call fileless, where the script will be embedded within WMI. The way it works is that you can set up the WMIs that when an event happens, being a logon or a timer or something else, then a script will be executed, and that script being on the disk or in WMI. A few years ago, we changed Autoruns so that it will show that entry, and I have an example here. When you have a WMI database entry, they link to an event and we show it as a way to basically keep persistence on the system. More recently, we changed Sysmon as well to see the same things. So we have 3 kind of events that show the different things that are happening on WMI leading to persistence. The glue between those events is the event 21, which is the binding event. It basically links the 2 other events. You have a consumer field that shows basically the action. What is the things that's going to be done when the event triggers? And it shows you the script that will be executed when that event happened. And then the filter is the event. It's basically a query that tells you that when a logon happened, then you need to do the consumer or the action. So if you set the Sysmon WMI event, you can see those things happening and you figure out that persistence was set up on that system. Finally, I want to leave you with best practices and tips that are useful for you. Install Sysmon on all your systems, been proven to work at scale. And when you have a problem, you always have the data on the system available. You should configure the events based on your environment, leverage the amazing community that we have, all the guides and all the discussions online so that you can know what's the good baseline, learn about new detection techniques, and then tweak that configuration for your environment so you can scale depending on what you need. And then once you set that up, you should forward the events to offline using Splunk, Sentinel, or something else so that you can do hunting and then you can search those events if something happens. So if an intrusion happened, you can come back in time and see what happened, and you can really understand how the attackers went on the network and moved and trying to get a clear picture of what happened there to remediate better. You can use as well for hunting and saying like you can use things like anomaly detection. If you see a binary that's used only on certain machines, you can track down and figure out what it is. That's something that was very important to us when we started Sysmon, to move from chasing attackers to more of a hunting. You should really take benefit of that. So thank you everybody for watching. I hope that was useful, that you learn more about how Sysmon was created, how you can use it, and learn about the community and everybody's work to try to improve it. So thank you very much.
When Mark and I were speaking at Microsoft conferences, TechEd in particular, the TechEd speaker room used to have a whiteboard, and they would show the highest rated speakers, the average rating, updated regularly throughout the day. So Mark and I had a fierce competition as to who was the higher rated speaker, and often it was neck and neck. Mark, I would say more than I, beat me out, but that was a source of a lot of cajoling and fun competition.
Well, hi. It's great to see people here at a conference again, sort of. I'm Aidan Marcuss, Global Techno Ninja at Tanium, and I'm here to talk about Autoruns today, the Autoruns tool in the Sysinternals suite. Yes, this is the book I co-authored, Troubleshooting with the Windows Sysinternals Tools. The reason this book exists is because I needed it. I needed it to exist. I've been a Sysinternals user since Sysinternals was NT Internals back in the mid-90s, and continued to use it through 21 years at Microsoft, and even today at Tanium, I use the Sysinternals tools all the time, and I needed a good reference book. Mark wanted the book to exist, but he did not have the time to write it entirely on his own. He needed a co-author. I stepped up, and I still refer to the book all the time. And by the way, it makes a great gift. The Sysinternals book, the Troubleshooting with Windows Sysinternals, it starts out with some Windows core concepts and getting started and things like that. It goes into, has chapters about all the major tools, Process Explorer, Autoruns, Process Monitor, and Proctom, and then has chapters about all the other tools. There's about 78 tools. Last I counted, 78 separate tools in the Sysinternals suite, not counting the native 64-bit versions and the ARM versions. So the book goes into great depth about all of them and helps you make use of them, helps me make use of them. In the back then, we've got Troubleshooting, Case of the Unexplained, named after Mark's popular troubleshooting sessions at TechEd and other events. And here we show how the Sysinternals tools are used in actual real-world troubleshooting and problem-solving scenarios. One of my favorite chapters in the whole thing is Windows core concepts. This is where we just talk about things that are relevant to Sysinternals tools users, and as far as I know, was probably the first and maybe only time that app containers was ever properly publicly documented. So I highly recommend this book. So today we're going to talk about Autoruns. Autoruns is the best tool that I'm aware of for identifying auto start extensibility points, ASEPs, ASEP. Auto start extensibility points are places in Windows that are configured to automatically run code when you do certain things like start up the computer, services and drivers load. When you log in, things are hooked into Explorer, or formerly Internet Explorer as well. Scheduled tasks automatically run on your behalf when you log in, when there's idle time, etc. What are all these things? Now, a lot of them are very useful for Windows, and Windows makes tremendous use of these auto start extensibility points. So does malware. Anything powerful enough to be used by anybody is also going to be used by malware. Autoruns is a great tool for finding that stuff and removing it. And also some of the unnecessary junk that gets installed on computers. We won't name names or anything, but removing that, identifying what they are and how to remove them or where to remove them from is a great use case for Autoruns. By the way, the book does talk about Stuxnet. So here's a screenshot from when Stuxnet was still this in the middle of being discovered, and Autoruns was used to do a before and after with Autoruns, take a snapshot of here's the state of the computer now, plug in the USB, do a refresh, do a compare, and see like, these two kernel mode drivers got added to the system, signed by a legitimate code signing certificate. So Autoruns helped diagnose and troubleshoot Stuxnet. Didn't help the Iranian nuclear program much, but there it is. It also has a command line version that can be used to enumerate all the auto start extensibility points through a console so you can output to a file, including to tab delimited text, which you type into the clipboard, and then you can paste it right into Excel and do sorting and all kinds of sorting and filtering and all kinds of useful things like that. All right, so enough of the PowerPoint. Let's just go in and have a look at Autoruns in action. So here's Autoruns. When you start up Autoruns, the first thing it does is enumerate a ton of auto start extensibility points on the system. and displays them categorized. So we have here things that happen at logon. We have things that hook into Windows Explorer or File Explorer, as they renamed it, all in one view. We can look at specific categories by clicking on these other tabs, such as logon. These are things that happen at the time of logon. Scheduled tasks that are configured, codecs that are configured on the system, etc. For each item, we have either a registry icon indicating this is configured in the registry, or a file system icon indicating that it's configured in the file system, such as shortcut files. For each of those, it'll say here is where it is configured. So this is the very popular run key, and the items inside the run key representing the AutoStart extensibility items for the run key for the current user. For each of those, it gives a name, typically from the registry value name, description, often from the file, the target file, whether it is signed and by whom, and whether that is verified or if there's a problem with the digital signature, and the target file that is being executed, as well as its timestamp. We'll talk about timestamps because those can be interesting. There can be lots of different types of timestamps. So for each of these, if we click on one of these items, in the lower pane, we can see additional information, the size of the file, the version number, and the complete command line that is invoked when that AutoStart extensibility point is started. Additional things we can do are to, if we see something that we want to get rid of, that we think this doesn't belong here, we can select an item and delete it. However, if you delete it, there's no undo. So another option instead is to temporarily disable something, just uncheck it. If it's in a per user location, all you need to be doing is running as that user. If it's in a machine-wide location, such as HD local machine, Autoruns needs to be running with administrative rights. So before we do that, let's have a look at some other things here. So if we're interested in actually seeing this location on the system, we can right-click this group here and click Jump to Entry. It'll open up the registry editor and take us to that location and select the key. In this case, if I had selected a specific item and did Jump to Entry, it would actually select the value that was running there. Now, as I said, if I disable this item, like that, in this particular case, how do you disable something in the run key? Well, let's go see when I uncheck that, what that actually did in the registry. Refresh the view here, and we see it's no longer there, but that a new Autoruns disabled key has been created underneath it. This Autoruns disabled key, Windows doesn't know anything about it, Explorer doesn't know anything about it, so it just gets ignored. But this is a place where we can stuff the items that have been disabled so that we can, if we want to, restore them simply by checking the box again. So I check that box, go back to the registry, have a look. We'll see Autoruns disabled is now empty and the value has been restored. Now I can also delete this item completely, and now Zoom It is no longer configured to auto run on this computer. However, note that it does not stop Zoom It from running if it's already running. In fact, it's right here, and I can restore that value simply by going in and checking that box again. If I refresh, we see it show up again. This is, by the way, something interesting that you should watch for when you are troubleshooting malware. If you find yourself deleting an AutoStart entry point like this, and it comes back, you do a refresh and it comes back, that means typically whatever it is that AutoStart is for is monitoring what you're doing and is making sure, no, you will not delete me. So that's where you need to go find the actual running processes and go take care of them. So additional value that we can get out of Autoruns, for one thing, like I said, Windows makes a lot of use of auto extensibility points, auto start extensibility points. Here is what hooks into Windows Explorer, and you can see a lot of these things are signed with a Microsoft Windows code signing certificate. Similarly, for services and drivers, lots and lots of things signed by Microsoft. Typically, things that are part of Windows are not the things you're looking for. And so by default, actually, Windows entries are hidden by default. And if I click that, we see that this goes way, way down. We see here a couple of Windows items. It says it's from Microsoft Corporation, but it's showing up in pink because this thing has not been verified. It's not, the digital signature did not validate. We'll come back to that in a moment. But we see here far fewer things hooked into Explorer, and we can further reduce things. If you want to trust everything signed by Microsoft, we can hide those as well, hide Microsoft entries. And on this particular machine, there's nothing hooked in besides Microsoft items. Let's go back over to drivers and applying that same filter. This is from Microsoft, or it says it's from Microsoft, but the signature did not validate. So what could be up with that? Well, maybe it is malware. It's not uncommon for malware to claim to be from Microsoft and put in the version resource, Microsoft, Microsoft Windows, etc. So maybe this is bad. How do we know? Well, another thing we can do, right-click the entry. Let's do this one here. Right-click, and let's check virus total. So virus total is an online service that has dozens and dozens of antivirus engines on it, and you can upload files to be scanned or the hashes of the files and say, have you seen this before? Now, this is an external service, and so you must separately agree to VirusTotal's terms of service. So I'll click yes here, and it will submit the hash of this file up to VirusTotal, and we get here 0 of 73. And what that means is there are 73 anti-malware engines on VirusTotal that analyze this file, or a file with the same hash, and none of them said that this was malicious. So we've got this unsigned driver file that nobody says is malicious. This is interesting. We click on the link. This is a hyperlink. And we can go here and we can see, yes, here are all the engines that looked at it. All of them said nothing wrong here. Click on details, says it's not signed. Well, that's weird. This always happens during demos. The problem here is this is most likely a legitimate system file signed by Microsoft. Now, the thing about signatures in Windows is most files, pretty much all the files in Windows are signed. However, very few of them have the signature embedded in the file. They're typically in separate catalog files. So let's jump to the image. And you see here, here's a bunch of other files. And let's take one that we know is signed. Let's have a look at this one. And we're going to use SigCheck for this just to validate what I'm about to say about it. We'll use the -I option and BTAMPM sys. Okay, this is signed. And you see here, this is catalog signed. The signature is not in the driver file itself. It's in this separate catalog file. And what happens from time to time is the catalogs and the files they're associated with get out of sync. And so signature validation fails, even though it is a legitimate file and has not been modified since Microsoft published it. This happens from time to time. I've seen it happen on a number of my machines very recently. So VirusTotal is a very useful way to double check things. You can also use VirusTotal to obviously look for actual malware. If I had some malware on this system, typically it would show a number greater than 0. And if I wanted to look only for those items, I could hide VirusTotal clean entries. Let me do one other thing here. I've only done these VirusTotal checks one at a time, but I could go, let's show everything again. And we have this additional scan option. Let's check virus total by default for everything. And what it'll do is it'll submit the hashes of all these files and ask, is there anything up there just based on the file hash? There is a separate checkbox for submit unknown images. If what'll happen here is, let's do that filter again, hide virus total clean entries. So everything with a 0 is going to be hidden. And you'll see here that there's a few with like 1. So work folders shell.dll, there's an entry. But here you can use this to filter everything that virus total says is perfectly fine. Click on this. Typically, you'll find when it's just 1 or 2, it's typically a false positive. You see, are there any unknowns? If there's, yes, nope. Okay, it's still submitting. It's submitting these one at a time, and there are a lot of files here to upload. In some cases, you may have something on the system that virus total has never seen before, and it'll say unknown, and it will show if you know, that's not considered a clean entry. It's not necessarily malicious, but in that case, the only way to get it checked is to do submit unknown images and submit that up. You may or may not want to do that because it might be that by doing so, you may be the victim of a very targeted attack. And if you submit an unknown image, if your system is the only machine, yours and the attackers are the only machine where it exists, if its hash suddenly appears on virus total, the attacker can also check virus total and can see, oh, they've submitted to virus total. They may be suspicious. We need to take action now. So let me show an additional cool feature here. Okay, so I commented before about that Stuxnet thing and setting a baseline, comparing against a baseline. You can, with Autoruns, you get your collection of AutoStart extensibility information, and you can save that file, save it as a file. You have two choices. You can save it as a text file or as a native binary Autoruns file, the star.arn, which captures all the information in a binary form. You can now take this file and send it to someone else. They can look at it on their system. They can open the file with Autoruns on their system and see all the information about the AutoStarts on your computer. Another thing you can do is use this as a baseline, come back and compare later. So I've done this. Let me go in and make some changes to AutoStart extensibility points. I'm going to uncheck zoom it, so I will turn off its ASEP. And I'll go into Process Explorer and turn on Run at Logon. This configures a scheduled task for Process Explorer. I'll do a refresh. We saw zoom it disappear, but now let's do File, Compare, and compare against the baseline we captured earlier. And we can see items highlighted in red are things that have been removed since we captured the baseline. Things in green are things that have been added. So here we see this Process Explorer ASEP added and the zoom it one removed. The next thing I want to talk about is the command line version. So you saw the screenshots earlier, and you saw these command lines. So this is what I've done: run Autoruns. Here, let me show the command line first. Oops, no, that's not the command line. That actually enumerates all the logon entries. Here's the command line syntax. So -A, and you tell it what you want, which auto starts you want to have a look at. Star for all. If you don't specify anything, it'll look just at the logon startups. You can specify that you want to look just at scheduled tasks, WMI entries, etc. You can output as, by default, you get that table view that you just saw, or you can print it out as comma separated values, -CT for tab delimited values. I use this all the time because you get tab delimited text, it pastes into Excel just like that, just magically. H if you want to get the file hashes, S for verified digital signatures. You can also capture virus total information as well if you want. You can specify just get this particular user account. And what I end up with is I paste it into Excel and format it nicely, and I get all this information. Then I can easily go in and filter and see, like, okay, what is it that I'm interested in? What is not verified? What is blank? Okay, and you can now go through and find the things that are of interest. And here are the drivers we saw earlier. One thing I want to point out, because there are some differences in timestamps. I did want to talk about that. So here you see timestamps, and they are all over the place. You've got some in 2017, 2018, 2021, and you've got some in 2037. And you've got some in 1902. That doesn't make any sense. What was built in 1902? Well, these appear to be Windows drivers. So what I was going to say about timestamps is there are basically 3 different types of timestamps. There's the ones in the file system. So NTFS will tell you this is the time that the file was created, when it was last modified, when it was last accessed. You also have signature timestamps. If a file's been signed, typically there will be a timestamp associated with that signature. Now, the file system ones are really easy to falsify. I mean, if you copy it from one system to another, you can lose the timestamps, and so they don't really tell you anything. They are really part of the directory of the file system rather than of the file itself. The signature timestamp, if the signature is validated and timestamped, that's going to be a lot more reliable. This is the time at which the file was signed. Finally, you have this thing called linker timestamps. This is built into the file itself with portable executable files in Windows. So that's EXEs, DLLs, drivers, and so forth. When the build tools build the file, the linker will put in a timestamp, or it's supposed to put in a timestamp in this particular field in the PE header, the portable executable header. And it would be right here in the header. And that gets translated into a date and time. If the file's been digitally signed, you can't modify that without breaking the signature. If it's not been signed, it's fairly easy to falsify that value. But it is often reliable enough that it can tell you this is when the file was built. However, that breaks in Windows recently because starting around, I think, Windows 10, so around 2015, the Windows engineers decided they wanted to have something called reproducible builds, which is to say, if you have 2 machines configured exactly the same, with the same build tools, the same source code, the same configuration information, and you build the same source code on both machines, you want both of those outputs to be, of the compiled executable, to be bit for bit exactly the same. And then if you go back and build it again on both machines, you want those also to be exactly the same. Now, if the executable file is going to have a timestamp baked into it of when it was built, you are pretty much guaranteed that those files will never be the same. And Windows engineers wanted to have reproducible builds so that they could have this consistency that the files would always be the same given the same inputs. So that meant that the timestamp field had to be no longer a timestamp. And so if you use a tool like dumpbin, or look into the PE headers and dig in far enough, you will find the flag that indicates that this is a reproducible build. Now, A lot of tools don't look for this, and Sysinternals, or at least Autoruns and Autoruns C by default don't do that right now. So depending on the context, the timestamp you see could be any one of these things: file system timestamps, signature timestamps, or linker timestamps. In the case of Autoruns C output, these timestamps are the linker timestamps for portable executable files, regardless of whether the timestamp field actually is a valid timestamp or not. So running low on time, there's so much more to cover. A lot of it's in the book. A lot of the KC Unexplained items use Autoruns. I recommend you get the book. I recommend Autoruns as well. It's a great tool. I've been using it since Mark first published it, and you should do the same. Thank you very much for your time.
Mark and I used to teach jointly a 5-day Windows Internals class. We each covered different topics. And he had, as I think many know the story, had written the Zoom It tool to overcome some limitations of some commercial tools that we used to use to zoom in on the screen and annotate during the sessions. But he added a great feature which I would use to help try to keep classes on time, and that's the break timer. And the default action on the break timer was when it got to 0, it stopped counting down, it went to a 0. And I had relied on that feature several times. I would take longer to come back on the break. I'd put a 10-minute break or 15-minute break and it would hit 0. And people are busy, they're not looking at the screen, and I'd come in and say, okay, time to start class, when in fact maybe it had been sitting at 0 for several minutes. Well, he knew about this problem I had. So one day I had a delivery at Microsoft. I'll never forget. I remember the building I was in. I remember the room. And I went out for a coffee break. I put a 15-minute timer. It's counting down, and I'm having my coffee. And I know it's past 15 minutes. I walk into the room, and there's like 70 people on a large amphitheater. And there, in huge red letters on the screen, is -3:02, 03, 04. And I said to myself, Mark, and of course contacted him afterwards and pleaded with him to put an option, which he did, to prevent the break timer from counting backwards in a negative number.
Hi everyone, my name's Andrew Richards and welcome to the Sysinternals Proctom section of the Sysinternals 25th anniversary event. As I said, my name's Andrew Richards. I have been the co-author of Proctom with Mark for about 10 years now, since about version 2 or 3. Also happen to be the host of Channel 9 Defrag Tools, was a series of about 200 episodes that delves into troubleshooting, so something else for you to dive in after the event. And my day job is a principal developer in Windows reliability, making Windows more secure and reliable as we go through the years. Today we're going to be going over what Proctom is from a basic level, not too deep a dive. It's got lots of features. We're just going to do the basics that will help you to become a better user of Proctom day to day, a better debugger of dump files, and basically be able to root cause or at least identify where you are with your crashes and hangs in your applications. Proctom is available at the Sysinternals website, sysinternals.com, also aka ms/procdump. The topics we're going to cover today particularly are what is the file that we make, why is it called procdump, what is this process dump file. We're going to get a debugger so we can open those files, and then we're going to go through two main scenarios, crashes and hangs. Collecting some dump files and then digging into those. So first off, what is a process dump file? What is this weird name? A process dump is a way of taking a file version of an application. Think of it as a snapshot. The process is paused, so it's kind of like not moving forward. And then all the memory associated with the process, so things like variables and globals, and also memory to do with maybe threads and stacks, plus metadata, things like kind of like performance counters and its memory usage and CPU usage. All that is captured and put into a file. The file is called a dump file. And over the years, there's been a couple of file formats used for dump files on Windows and also on other platforms. Proctom uses the mini-dump file format, which is not to be confused with the mini-dump mini-sized file. The mini-dump file format allows you to specify a range of sizes, so you can have a mini-dump, a mini-dump, all the way up to what we call a full mini-dump, which is all the memory that is possible. Proctom always writes its files using a .dmp extension. Windows error reporting sometimes uses, in certain scenarios, HDMP and MDMP. They're still the same file format. It's just an indicator that this file has heap memory in it versus mdump, which would be mini size only. All the same file format. It's just, as I said, a hint as to what the file can do. The capture of a dump file can be done in various sizes, and the main three are mini, all, and mini plus, which is kind of in the middle. Mini is what Windows error reporting uses. It's the simple, just what's required to understand the situation, but you won't be able to do that deep dive analysis. Mini all, complete end of the spectrum, it's everything. It's all the memory. And then in the middle, there's a one called Mini Plus, which is a proc dump concept where we try to just get what's required, but kind of be sure, or try to be sure about we do have enough memory to investigate a situation. If you have a really big server, where say like maybe 100 gigabytes, it's a way of bringing that down to a more reasonable size in the 10 to 20 gig range, for example. There's a couple of rarely used things. Triage dump files, the same as Mini. Windows has a heuristic that Proctom uses to try to identify PII and change that to AAA in hex. The idea being we're trying to remove strings and personal information. It's not guaranteed, it's heuristic, but that's there. Mini custom, in the bottom of how this works, it all comes down to a hex bit mask. And so you can just type in that hex bit mask directly rather than relying on one of the pre-baked numbers. MD is for a DLL callback. So if someone wants to be a mini dump, write dump callback, which is this thing you can look and understand, you can provide that DLL. And then there's kernel, which is slightly different. So all of those so far define how big the file is going to be for the user mode dump file. You can also attempt to take a kernel dump file as well at the same time. So you'll end up with two files for the capture, and it takes the kernel side of the process. And You use that particularly when you're doing hang analysis, where you want to, the user mode code is waiting on something and you want to see why it's waiting in the kernel. You can use VMAP to get an idea of all the different segments of the process and what may or may not be brought in. Things like image, map files, and heap, the various types of private memory heaps and stacks, and private memory itself are the main things that we're playing with here. Proctom defaults to a year, month, day, hour, minute, second file name format if you don't override it. If you happen to take multiple sizes at the same time, and whether this be I want a mini and a full at the same time, for example, or a mini plus a kernel, you'll get a suffix of that size. Pretty rare that you need to override it as a different file name, but the option is there. So let's jump into a debugger session and just collect some dump files. So I've copied procdump into a dumps folder. And what we're going to do is just going to run Notepad and take some dump files of it. So without any options, it's going to take a mini dump. And what it's going to do is match anything with the name that's unique enough. And as long as there's one, it will be happy. So for the case of Notepad, there's only one. That was a mini. So I'm going to do a mini plus as well, MP, and mini all, or memory all, MA. And if we look at the folder now, we've generated 3 files, and you can see seconds went up as we ran each one. And this was the mini, 700K, mini plus 30 meg. The memory all, the full was 100 and something. So you can see that variety of sizes that you can get. And as I said, these two are roughly the same as from a debuggability point of view. If you are running, debugging or dumping like a really big process and it may not succeed because it's so long or so hard to dump, you actually can take multiple at the same time. So the idea is you get a smaller one guaranteed, and then the big one may or may not succeed. So pushing this to the extreme, I'm going to take 3 files at once. And you can see that all 3 were taking at the same time. And in this case, because they were like a set, the size is put on the end. So let's jump back into what are you going to do with these files? What's the next step? So we need to get a debugger. Microsoft produces 2 main debuggers, the Windows debugger, which is a very CLI command line approach to debugging, and Visual Studio through code and all the other variations of Visual Studio. That's more of a GUI-based approach. Today, we're going to be using the Windows debugger style of it, the CLI, because I want to show you the nitty-gritty details of what actually is in a dump file. Within that space, there is 2 options. For the last decade or so, the debugging tools for Windows has shipped in the Windows SDK. And more recently in the last couple of years, there's now a Windows Store application called WinDBG Preview, and that's what we're going to be using today. The debugger is extensible. There is a plugin framework, and so you can add extensions of various types, particularly 2 extensions that are worth adding to your toolset are PDE and MEX. PDE is very good at debugging UWP applications. It has a whole lot of tool commands to help in that space. And MEX is much more kernel focused. So this is more your kernel blue screen dump file. Suggestion is pull them down from their website and just put them in the same folder as your dump file folder. I find if I put all the files together, I don't lose them. So let's have a quick look at where those are on the internet. So WinDBG is in the store. Get it, install it, pretty easy. Procdump is on Sysinternals.com, www.sysinternals.com, or aka MS Procdump. The Windows SDK continually evolves as Windows evolves. You can download the ISO version of it or the installer. You only need to choose the debugging tools out of the package. You don't need to choose everything, so it's only a couple of megabyte download. MEX is available on the Download Center. It's a zip exe, so you just download it, extract the DLL, and then use the DLL. PDE is available on the Defrag Tools, Channel Defrag Tools homepage in this OneDrive link. Also, if you want to dig in deeper, and particularly for the MK option, the mini kernel option, memory kernel option, Defrag Tools episode 178 goes into deep detail about what that looks like and how to use it and what scenarios. So let's talk about what you're going to do with a dump file once you have it. If you don't know really anything about debugging, the easiest thing to do is open up the file in WinDBG, either the old one or the new one, and just run bang analyze -v or bang analyze pure. This is the same engine that Microsoft uses to back Watson and our telemetry, and this is how we map bugs against issues. And so with no debugging knowledge, you're really going to be driving, getting the insight that Microsoft provides with the bang analyze tool. But let's do it ourselves. Let's dig into real world environments and move from there. So the first step is to get some dump files. Crashes are a good way to start, and they're easy to find and semi-easy to do. Operating system has a thing called AE debug. It's part of Windows error reporting, and when a crash happens, it runs the AE debug handler. And so by installing Proctom as the AE debug handler, you're going to get the an opportunity to collect a dump file out of crash. To install it, it's from an elevated command prompt, Proctom -I. The folder is optional. It uses the current folder by default. The size, if you don't specify it, will default to mini, which is a little bit small. So you actually want to specify a size. If you have hard drive space, do memory all. That way you guarantee to have everything you need. If your hard drive is a little bit smaller, use mini plus and collect your files. And then the opposite, just use -U to uninstall it. So once you've done that, and we can show you that in action right now, I'm just going to install it, get full dumps, install, uninstall, oops, uninstall. You can see it deleting the registry keys and adding the registry keys. So in this case, we've got it installed. I'm just going to go in here and run a crash app. And it's going to run two of them, two different type of crashes. And you can see that it generated some files. And it's always going to be 2 per system. The reason why you get 2, sorry, I was switching screens then. The reason why you get 2 is because the operating system tries 2 times to resolve the situation. The point of AE debug is to ask someone to fix the situation, not to collect a file. And so in that case, we don't fix it the first time. All we've done is dump the file. Windows error reporting calls you again, and then after the second time it goes, okay, obviously this can't be fixed, and then continues on to finish the application. Because of that, you can just delete the second file. Now you notice that this one's got a .1 or -1. That's because that was the second dump file taken in that second, and in this case, it went over the second boundary. So the second moved up, so you can delete those. When it comes to the debugging of them, the main thing you want to do is follow these steps. This is the general steps to run when you have any generic dump file that's a crash. Last event is the first command you want to do. It tells you on what process and what thread the issue happened and what exception it was. Just gives you a general idea of what context this happened in. ECXR -1, exception record. The -1 tells it to read the parameters, exception parameters out of metadata, i.e. out of the dump, rather than out of memory. And what it's going to do is give you an extra level of detail about the parameters and the reason for the issue. ECXR, exception context record, will change the default focus of the debugger to the throw. And what I mean by that is when the issue happens, it is thrown and then it is caught. So it's caught by Windows error reporting. What we want to do, and then the state has changed because Windows error reporting is running, we want to wind back time, the registers, the way that the system looks, back to the throw and look at in that context. The K command, which is stack, works at any time. If you follow this flow, it will be the call stack off the crash. There's one specialization, well, there's lots of specializations for exception code, particularly there's a specialization for CLR exceptions. If the code is CLR exception, and you'll see that in the last event output, then you want to run .core DLL -L for load, and that will load additional infrastructure in the debugger associated with CLR debugging. And particularly, it will make a command called bang PE, which is a shorthand for bang print exception. And that will have a more rich way of printing out the exception. So it's kind of equivalent to ECXR -1, but it's specific to CLR exceptions. So let's have a look at some of these dump files that we've been creating and see what that looks like. Opening up Proctom, opening up the Proctom crash file in WinDBG. Right away, I'm just going to press K. You can see that we are in Windows error reporting. The crash has happened down here. It's gone through Windows. Windows error reporting is kicked in. And this wait for multiple objects is actually waiting for Proctom to take the dump file. As I said, you can always run bang -v at any time to get the answer. But we're going to go into the specific details. So .last event, just to show you what happened. So on process this number, thread this number, there was an access violation. The tilde command just happens to tell you where the debugger is currently right now. Same numbers, but because this is set, the debugger will default to the same thread. Just the fact that it's thread 0 is by luck, not by design. Next command is EXR-1, show me the exception. In this case, an access violation. The 1 means it's a write, so 0 is read, 1 is write, 8 is execute, and then we have the address it tries to reference. If we do ECXR now and change our register context, you can see that the debugger has transitioned it from really the catch, which is what this is, to the throw. And here's the line of code that crashed. So let's quickly do that for some other dump files that we have on this box. .last event, divide by 0, so we already kind of understand what we're doing here. Exception record, no additional parameters, change the context, and then you can see the line of code and the instruction that crashed. More commonly is when you do this in real life. And so for the -I example, these have happened on my box, and all these ones I've kept around on my box for examples. Last event, access violation, -1, parameters. This time it's a read because it's a 0 and a different address, ECXR, and then we can look at the code and we can see that there's a fault in the install service. Let's look at, actually I'm going to open both these up. Next time, this one is a security failure. Looking at the number, it is of subcode 7, which is a specific thing, which is app exit. It has this error code. So we can say, what does that mean? Class is configured to run as a security ID, blah, blah, blah. Change the context, look at the code, and then you can see the line of code is reporting the failure. So it's somewhere around here that the fault is. This last example that we have from our hard drive, last event, CLR exception this time. You can see the CLR exception code, 5 parameters. There is an error number right there. Now the F's are on top because it's sign extension. So because the last bit, the top bit of the 8 is set, when you cast that 32-bit number up to 64, the 1 is repeated. That's how like -1 works. Negative numbers work. So here's our error. In this case, we can jump to the context and you can see CLR being busy, but what you really want to do is follow those steps, call DLL -L to load. You can now see it's loaded, and we can do PE for print exception, and we get a much better view of the world. And in this case, you can see there's some dictionary code going on. Argument exception, an item with the same key has already been added. So the same key was added to the dictionary. You can see the calling code. If you had symbols, you could dive into a bit more. And once again, the same error code as we saw above. All right, so very quick whirlwind way of looking at crashes. So let's start looking at where the power of Proctom kicks in and start using some of its tooling. There is 4 or 5 different ways that Proctom can do collection. We can do it based on CPU going too high or too low. So if a process runs away on compute, or under runs away, it goes under. The pair to that is memory and performance counters. If the memory goes too high or too low, or if a performance counter goes too low. And the other ones are more kind of like state machine weights ones. You can do it based on an exception. So if you may have a throw that is caught but the throw represents a situation that causes maybe an application to become unstable rather than being critically killed. So that's what exceptions is for. -H is hung windows. That's when you want to diagnose into a gray screen where an application freezes and ghosts. And then the other one that's not used very often is terminate. That's when you literally terminate yourself. You can call the API process terminate, self-killing. So you want to find out what code caused that. And then how many seconds applies to those things. So how many seconds in a row does it need to happen? So let's use Proctom again to trace Notepad again. This time we're just going to do CPU. Now I don't know how much CPU Notepad uses, so let's just start with 99%, like nearly all the CPU of the box. And what I'm going to do is just type a lot of stuff and copy paste it. And then we're going to run Process Explorer at the same time. And we're going to find this process. And we have its performance graph. So here's its CPU usage. So what I want you to do is pay attention to here as I paste, and also pay attention to Process Explorer's count. So as I'm doing this, the pasting, it's kind of expensive, 1%. I'm going to copy a bit more, so there's a bit more involved in the paste, like the whole document. And it's hovering around 4 or 5%. So this time I'm going to reduce the load to 2% and keep on pasting. And now you can see, look, we've noticed 4%, 6%, but I'm going to let go. And so because we haven't got to the seconds, the number of the seconds by default is 10. So we can cancel that and go, look, I only need it if it lasts 3 seconds, for example. And I'm going to get a full dump, for example. I'm going to continue my pasting, triggers triggering, and then we've made a dump file. And then if you open up the dump file will default to the thread that had the most usage. And if you use the command bank comment, you can see what Proctom observed and on what thread. So more, that's like kind of like the performance counter view of the world. So let's do something a little bit more invasive, and let's look at Proctom. So let's look at this Trace Explorer. So I'm going to look at Explorer, and I'm going to filter for nothing. So I could filter for something that doesn't match, or a blank string. You can't match a blank with a non-blank, so that's also guaranteed. And we're just going to look at Explorer. And so I'm going to use Windows pause to bring up the About screen, and then I'm going to close it. And you can see there's a slew of events on the screen. MSC in lowercase ASCII is actually 6D7363. This is Microsoft C, so this is the C++, C++ exception code. And you can see these are all C++, because they're kind of codey, kind of normal. This one's kind of weird, the 4001. So let's catch that guy. And I can choose to match anything. Any part of the string can be matched. So I could use this part, anything that matches. And I'm going to say, you know what, I want the first 2 of these, 1, 2, but I don't want the third, for example. So run up the demonstration again. You can see the first one capturing. It's going to skip over the C ones, and then you can see the second one capturing, and then it ends because we've satisfied the queries. Opening up one of those dump files, we can follow the same steps for crashes in this case because it is a crash scenario. The slight difference is Proctom has taken the dump file at the throw, not at the catch. So we don't need to change time at all. We can just do last event and see, yep, when times, there's the error code. Show me the exception information. It has 3 parameters. Once again, it has a code. And we get an information about that. And it said, because we're at the throw, not at the catch, we can just press K and see the code. And you can see some reporting code, and this is the code around here somewhere that originated the issue. Okay, so looking at that in text form, We can take dumps at first chance and second chance. First chance, the -E1 is when something is thrown. A second chance is when it didn't get caught and it crashed. It's exactly the same scenario as you can go -E2 or -E nothing. Same scenario as what would happen if we had the code written as an install handler -I. So it doesn't tend to get used. You can use more than one filter. You can use positive and negative filters, including and exclude filters. A whole lot of examples. I won't go through them right now. And then, as I said, this is the thing that we traced before. Some really esoteric options that we'll just quickly go through. -B treats breakpoints as exceptions by default. A breakpoint is ignored and just continued when we're doing exception monitoring. But if the breakpoint is needed to be caught, you can add -B. By default, because of limitations of CLR and the OS, if the CLR is detected in a process, we only do CLR monitoring and we don't do native, like normal Windows monitoring anymore. If you are trying to catch the native exception, use -G to ignore that interop across the CLR and stay in the native debugger. -L is a log output. This is output debug string, so you can see that on the screen. And -T we talked about before. Reflection and -A, avoid outage, allows you to take the dump file on a clone, so on like a fork in Unix. And so if you have a process that needs to continue for maybe production reasons, or say that it's maybe just producing video content or something, you can make a clone, which is like a snapshot, and then it does it in the background. Avoid outage if Proctom knows it's in a situation where it's having to pause the application for too long. Rather than taking a dump file, you can use avoid outage and it will miss taking the dump file rather than avoid an outage. In some very rare situations, you want to kill the process after you've collected it, -K. When you're doing CPU tracing, the scale is between 0 and 100. But if it's only one thread on, say, an 8-core box, it means its range is really only between 0 and 12. And so what you can do is by adding -U, instead of that range being 0 to 100, it changes it, say, to 0 to 800 if it has 8 CPUs. And then you can use a number between 0 and 100 to represent that. It's a way of giving granularity. You don't have to have the process already running. You can use -W for wait. It just does a poll every 500 milliseconds to see if it can find the process. And risky, if you're a Windows on Windows 64 debugger within Microsoft developer, then you need -64, super rare. So hopefully that was a understandable and easy way to get into the basics of WinDBG. Hopefully I've inspired you to practice your debugging. At least install the debugging tools, install Proctom -I to get your local dump files collected, and open up a couple. You'll get, a couple of dump files every little while. Sometimes you'll have stable periods, sometimes you won't. It's really hard to tell when you're going to get dump files, but open them up. Last event, ECXR -1, ECXR and K to get an idea of where you are, and it gives you an idea of what's the next steps are. If you want a much more deeper dive, there's a whole slew of videos on the Defrag Tools series about Sysinternals in general, and there's a good 10 or 20 on debugging. Hope you enjoy the rest of the conference today, and thanks for listening. Bye.
When Mark and I started to collaborate on the book, I did go to Microsoft. I went to one of the key members of the Windows NT development team at the time, Lou Perisoli, who was overseeing, I think, all of the kernel development, and mentioned the idea of collaborating with Mark Russinovich. And at that time, Mark was not on the most friendly terms with Microsoft, especially with the NT group. So basically, I said, I can vouch for Mark. He's seen the light. He wants to be a friend of the family. So I remember Lou's telling me, Dave, okay, you can work with him, but if he messes up, it's your head. We started to work together on the book, and then talking to Mark, we decided to make a request for him to have source code access. We thought that would accelerate and help with the book effort. Of course, Mark was able to do all the work without source access. But we made the request, and that, of course, went to higher authorities. But sure enough, it was approved. They prepared the license agreement, and we were both in Redmond. I think I was there teaching another class, and we were given the source code agreement. I presented it to Mark. Mark looked at it, and I remember in the conference room, and he said, "Dave, I can't sign this." And there were some clauses that conscientiously Mark couldn't sign because it said anything that he learned or discovered based on looking at the source code could not be used in his commercial programs. And the commercial arm, Winternals, the company that Microsoft purchased, did have tools that were products based on Mark's reverse engineering. So if he saw some of this inside information in the source code, that could potentially prevent him then from selling these commercial tools. So he had to say no. But what an embarrassment to go back to Microsoft after basically making a case that he could be trusted to see the source code and tell them, sorry guys, he can't sign.
Hello and welcome to the PS Tools party here at the Sysinternals 25th Anniversary Festival. I'm Aidan Marcuss, Global Techno Ninja at Tanium. And yes, that's my name on the cover of the book. It's there because Mark needed a co-author to help bring this book to life. He didn't have time to write it all by himself. And as a longtime user of the tools, I needed this book to exist. In fact, I've reread a few chapters in preparation for this event. This session is about the PS tools, a set of Sysinternals utilities that share some characteristics in common. Specifically, they're all console utilities, command line utilities, meaning you can use them in batch files and scripts. They write their results to standard output or standard error, where you can redirect them to files, unlike graphical GUI tools. Also, the PS tools, for the most part, can operate on the local computer or one or more remote computers. And there's a consistent syntax among all the tools for how to specify remote computers as well as alternate credentials to log on using a different account to connect to the remote machine. One of the tools, however, is not like the other ones. PS Ping is a comparatively new Sysinternals tool for network diagnostics. It's included in the PS Tools zip download, but it's so different that it's not even in the same chapter in the book. So here are the tools. Here's the full set of the PS tools. They serve a variety of purposes. To be fair, some of these tools aren't as useful today as they were when they were first written. With the exception of PS Ping, they all come from a time when Windows was still focused on its graphical interfaces and offered very little in the way of scriptable management, and long before PowerShell was even conceived. But some of these tools still offer features not found elsewhere. I'll demo some of them, including some that I still use all the time. Let's start with these three utilities. We'll start with PS-GetSID. A SID, a security identifier, identifies a user, a group, a computer in Windows. All these items have a SID, and there's a translation between that and a name. For example, the SID for the administrators group on a US English system is S1532544. So with PS-GetSID, you give it either a name or a SID, and it'll reverse it and give you the other thing. Now, in this case, S1532544, this is what actually identifies the administrators group. Under the covers, Windows does not use names. It uses SIDs, the security identifiers, to identify things. This is a US English system. Let's have a look at a French system. Here's a French system, and we'll bring up PowerShell and run that same command, PS-GetSID. And no banner is, if I don't do no banner, it gives you copyright information. So here, I'll do it both ways. So no banner gets rid of this copyright stuff and just gives you the data you're looking for. But you see here, S1532544 on a French system is not administrators, it's localized. Also, may not know this, but NT authority is localized as well. Here is the SID for the local service account, and on a French system, it's this. I'm not going to mangle French, but this is not the same as it is on a US English system, as you can see. Another interesting thing you can do with PS-GetSID is get SIDs. Not all SIDs are defined on all systems. So for example, 549, this is on the Windows 10 system, it's not defined. However, these SIDs are defined on domain controllers. So what we can do is, using the syntax to operate on a remote computer, we can query a domain controller. In this case, this is my domain controller, have it do the translation, and we see that it is, in fact, the server operator's SID. And let's have a little bit more fun with PowerShell and look at a series of these things, 548 through 550. And we see none of these are defined on the local system, but if I run a command against domain controller, it's account operators, server operators, and print operators. Now, why is this useful? Well, you're going to run into SIDs all the time, and getting the translation, you can do it in PowerShell, but it's a rather long, complex command. I've never memorized it. PS-GetSID is way more convenient for me. I use PS-GetSID quite often. Here's another example. If you run PS-GetSID without any parameters, it will give you the SID of the local computer. So all local accounts and groups, locally defined groups other than the built-in standard groups, are all going to be based on the machine SID. So if I do ps-get SID, and that SID, of course, is just going to give me back the computer again, the -500 account is the administrator account, might be renamed. In this case, it's not. Let's do the same thing on the French system. Add the -500, and you'll see it's also not renamed here, but it is localized. So on a French system, the -500 account is not called administrator. This can be very important to note. So it's tremendously useful for this kind of getting the SID when you need the SID, getting the name when you have the SID. So that's ps-get SID. The next tool I want to talk about is ps-suspend. And what this tool does is it, as you would suspect, suspends processes on a local or remote NT system. Obviously, this code was written a long, long time ago. It works perfectly fine on all modern Windows systems, but let's have a look at how this can be useful. Let's first of all run something that is going to need to be suspended. We'll run a couple of them. This is a test app, and this one's going to have one thread running continually, and this one will have 2 threads. And let's look at Process Explorer. Let's hide all these, everything launched by WinInit. And here's virtmem test. And you can see here, one of them is consuming almost 50% of this 4 CPU system, one of them 25%. You see the CPU usage has gone way up. Now, if you have a system and you've got code running, I could kill these processes, but if they're doing useful tasks, I don't want to kill them. However, I could use ps-suspend to pause them for a little while, and I specify either a process ID or a name. I'll do virtmem test, and it'll find all instances of virtmem test and pause them. You can see here they're running, and now they are suspended. And Process Explorer shows in gray that they're suspended. If you go in and look at the Threads tab, you'll see that the suspend count for each of these threads is now 1, and these things are not running. Now I can, with the system not bogged down anymore, you can see the CPU's gone way down, I can do whatever I need to do, then come back and use -R with ps-suspend and allow them to continue doing their work. There's another use case for ps-suspend, and that is if you have malware running on a machine and you kill the process and it comes right back. What that typically means is you've got malware operating in a buddy system where you've got 2 or more instances of these processes monitoring one another and watching for one another. And when one of them is terminated, the one that's still alive will start a new instance of that process. And so killing them won't work because you need to kill them very, very quickly in order for the buddy not to, I mean, if the buddy is running at very high priority, it's going to be really hard to kill all of them in time before they start up new instances. So what you can do instead is to suspend them, because I've yet to hear of an instance of this malware that will watch for something being suspended rather than being terminated. So now they're suspended, and now you can go in and kill them. And if you've ever seen Mark do Case of the Unexplained and talk about how to put them to sleep before killing them because it's more humane, he always loved telling that one. The tool to use here, if it's a Sysinternals tool, is ps-kill. ps-kill allows you to terminate processes either locally or on a remote computer. Obviously, you need to be admin on the remote computer to do that, or have admin credentials. Specify process ID or name. And with the -T option, you can also kill any descendant processes, any child processes belonging that were started by it. ps-kill virtmem test, and they're gone. So next, everybody's favorite tool, or one of the most popular of the PS tools, is ps-exec. ps-exec is a tool that allows you to run processes on remote computers or on the local computer in a different security context. Yeah, there are other ways of doing this kind of remoting now in Windows. You've got PowerShell remoting, for example. ps-exec is still a rather useful tool for a number of different reasons. It is also, by the way, though, often flagged as malware. Let me switch back over to the slides for just a second. Here's the command line. And I do want to say PSExec is not malware. It does not exploit any vulnerabilities. It does not offer any unauthorized elevation of privilege. It doesn't even use any undocumented or unsupported interfaces. That said, it's a powerful tool, and therefore PSExec is often used by malware, but only as a post-exploitation tool. PSExec can do nothing to benefit the attacker unless the attacker already has control of an account with admin rights. PSExec, you can specify the remote computer. That's optional. You can operate on the local computer as well. Some of the best options, some of the favorite options are -S to run a process in the system account, to run something interactively. I'll demonstrate that. To run the WinLog on desktop, that's a fun one. I'll show you that. Very few real use cases for it, but it's fun. So we'll definitely do that here. So first of all, let's show you what happens when you run PSExec on a remote computer. Now this is the domain controller. I'm coming in as a member of domain admins, and I'm going to run command prompt on this computer. And let's see if we want to see that instance here. There it is. PSExec service launches cmd.exe. You know what? I'm going to run this as admin so we can see all the information. Right, so there's cmd.exe running in session 0 as the domain administrator. But you don't see anything showing up on the screen over here. It's over here. What's happening is it has launched cmd.exe, command prompt, and is echoing text back and forth between the computers. So it's like a remote shell. So if I do host name, I'll see the host name of the target system. If I do who am I, it's the account I'm running as. ipconfig 20.11 is the client computer over here, not the one I'm running from. So I'm running this remote shell as domain admin, which is the account I was running as over here. If I exit out, you'll see those processes go away on the remote. Let's do that again, and this time specify -S. I'm going to run as local system now. And you see here that cmd.exe is now running as local system on the remote computer. Another fun thing to do, though, is to run something interactively on the remote computer. Most of the things here are running in, this desktop is running in session number 2. So if I specify -I2, that says run it in interactive session number 2 on the remote computer. And let's not wait for it to return. So -D says don't wait. I'm now running this command prompt in an interactive session as local system. That can be a fun trick. So these are things you can use. So you can run all kinds of remote things and perform remote operations within PSExec. What I most often use PSExec for is when I'm doing troubleshooting on a machine, I'm running as with an administrative account, running elevated. I want to run something as local system. I can run PSExec and just run directly on the local computer. So I'm now doing a remote to the local computer. Here again, this is running in session 0, non-interactive, and echoing the text back and forth. By the way, if I try to do something like clear screen, it's not going to work because it's running in a different context. It has no idea about what window this is actually running in. What I can do instead, and what I do sometimes, is run interactively in the current context and also don't wait, PSExec-SID, CMD, or PowerShell, and I've got stuff running as local system. This can be really, really useful when you're doing advanced troubleshooting and you need to look in areas that the administrative account can't look at. So for example, I can go into system volume information and poke around if I need to. I can also go into the registry and go into the local SAM, other areas of the registry that are typically available only to the system account. Have a look at permissions here. Administrators has practically nothing. Has permissions, has the ability to modify the permissions. Don't do that, by the way. Never, ever do that. System has full control. Better to run something as local system and not mess with the permissions. This is tremendously useful. So the next thing I want to show is a cool trick. And for this, I need to go into the console session and run from there. Because what I'm going to do now, by the way, where am I running? I am still in session 2. Okay, we'll see. PS Exec, I want to run something on the WinLog on desktop. I need to run a system, so -S. WinLog on desktop uses the X switch, and then D says don't wait for it to return. Interactive session 2, and we'll run cmd.exe. Okay, so now I am running, where is it? Oh, it doesn't have a parent process because I didn't wait for it to exit, so it doesn't have a parent process anymore, but here it is, running as local system in session 2. And if I look at the handles, actually it's not going to show the desktop handles, but where is it? Where is this thing? Well, let's lock the computer. So lock, we're at the logon screen. Okay, Alt-Tab, there's a command prompt on the logon screen. This is the WinLog on desktop. Who am I? System. You have to be running a system to do anything here. I'll run this tool I wrote a while ago called TS Sessions and have a look at where exactly are we. We are in session 2 in the interactive Windows station on the WinLog on desktop. Why would you ever need to do this? If you're writing code that needs to run on the WinLog on desktop, like you're creating a logon provider or something like that, and you want to run your tools like Spy++ or something like that to verify what's happening on the desktop or to manipulate it directly, this is a trick you can use. That's the only valid reason I could ever come up with for running something on the WinLog on desktop. That and scaring the you-know-what out of people. And it timed out, so there we are. So exit this. Okay, that was fun. Let's have a look at the newest PS Ping. So PS Ping is a network diagnostic utility that offers standard ping capability using ICMP, the Internet Controlled Message Protocol, as well as doing other probably more useful network diagnostics. One of the advantages of PS Ping over the regular ping is the higher resolution. Let's have a look at that right away. If I ping a machine and it responds, it's giving me the resolution in milliseconds. In the mid-90s, when this capability was first being invented or deployed, that was probably fine, but in 2021, it's not really as useful as what we could use. PS Ping, with no other parameters, does basically the same thing as ping. It uses ICMP messages to measure how long it takes to get a response back using ICMP. A couple differences you see here. One is greater resolution, hundredths of milliseconds rather than just milliseconds. Another thing also is it'll do a warm-up before it starts counting the actual statistics to make sure that the software on the remote side is up and running, because you don't really care typically how long it takes for that to come up, especially if it makes the numbers take longer. Once it's at a steady state, that's when you want to start measuring. So you have the ability to add a -W option to say how many warm-up pings you want to do first. So here are 3 of them before it starts counting any of the actual statistics. Now, the thing is that ICMP works fine for the most part on your internal networks, but when you go out on the internet, it's typically going to be blocked. So if I do psping sysinternals.com, it's not going to respond. Sysinternals.com has a web server, but they're not going to respond to anybody just asking, hey, what are your ICMP statistics like? So what you really care about anyway is, can I connect to the web server, and how long does that take? The difference in the syntax between the regular ping and ICMP and the TCP ping connection latency is basically just add colon and a port number, and the rest of the syntax is basically the same. So Sysinternals is listening on port 443 for HTTPS. And that's what I care about. How long does it take to establish a TCP connection to that port and then tear it down? And that's the measure you get here. Additional things you can do, again, you can set a different number of warm-ups with -W. You can also say, don't wait 1 full second, just 0 interval between the connection attempts. You can also specify, hey, I'd like to do more than just 4. Let's do 8. Use -N to increase or change the number. And another really useful thing is to do a histogram. So what can we do with histograms? First of all, let's bump up the number and get 50 of these. And let's do -Q because all these intermediate results, we don't need to see all those. And we have latency going everywhere from 68.82 milliseconds up to 377.02 milliseconds, and a count of the number of results landing inside that bucket. So what can we do with that? Let's do that again, capture it to the clipboard, and we'll bring up Excel, paste those results in, and let's zoom in on this. Yeah, we've got one outlier, and so they're all in this one bucket here. Let's try another one just to see if we get some more interesting results. Those single outliers can mess up the bucketing. Here's a little more interesting. So we'll zoom in on this, and we can graph the results. Oftentimes you'll see something a little bit more like a bell, but in any case, this is fantastically useful functionality. So there's additional tests we can do that require that the server cooperate. So what we'd like to do is see how long does it take to upload or download data, and how much bandwidth can the server take. To do that, you need to have something on the remote computer that's listening and cooperating with you. And that's where PSPing has a server mode where you set up a listening instance of PSPing, and then your client can connect to that server. So here, -S for server mode, the interface you want to use, and the port, and then -F if you want to create a temporary firewall rule allowing connections into that port. So now it's listening, and we can see here that now PSPing is listening on port 1001. And if we have a look at the firewall rules, we'll see there is a Sysinternals PSPing rule temporarily created allowing connections in. So now we can do things from the client. We're going to send 1 meg at a time. We'll do that 100 times. And we can see it went from a minimum of 0.92 milliseconds to 7.45 for each of these instances, for 100 separate instances. We can also do histograms. We can ask it, okay, let's go the other direction, send the data from the server to the client with -R. How long does it take to send a meg 100 times and get the range of values for each of those? So I would love to show you how we can use UDP. We can measure UDP performance. Again, that requires the server to cooperate, because UDP being connectionless will not, it's kind of hard to measure UDP unless you have two sides cooperating really well as testing bandwidth. Anyway, thank you very much for your time. Enjoy the rest of the conference.
My greatest pleasure speaking with Mark at conferences such as Microsoft TechEd was after a session, and usually we had very large crowds, people would come up to the front, and I'd often receive thank yous for working on the Sysinternals tools. I gladly accepted credit, and that annoyed Mark to no end.
Good afternoon, good evening, and good morning, everyone. Thanks for joining us on this awesome day, which is the Sysinternals 25th anniversary. We had a lot of good sessions today. This session, we're going to do something just a little different. It's still around Sysinternals, but it's going to be around Sysinternals for Linux. My name is Mario Hubert. I'm a principal customer engineer. I joined Microsoft back in 1998. I've been in a few different roles in Microsoft through that time. All of it has been in software engineering, but sort of the thread and the theme and what I'm passionate about is software reliability and robustness. And as part of that, I've gotten to use the Sysinternals tools for a long time, the various debuggers and things like that, to be able to get a glance at the internals of the system. As part of that passion, I wrote a couple of books. One is Advanced Windows Debugging, which covers the Win32 API layer, and then I followed that up with the .NET, Advanced .NET Debugging, which is deals with the .NET and the CLR. And I've also got a couple of debugging diagnostics Pluralsight courses out there. And with me today, we've got Mr. Kevin Sheldrake. If we're really nice to him today, he might actually divulge a secret announcement, possibly. So, Kevin, do you want to give a quick intro and take it from there?
Yeah, so hi, I'm Kevin Sheldrake. I work for Sysinternals in Microsoft. I'm a senior security software engineer. Before I came to Microsoft, I had a long history in Linux security, from penetration testing to reverse engineering, both at some conferences, got published here and there. And right now I'm working on Sysmon for Linux, which we are going to launch today. So Sysinternals have obviously already released a couple of tools on Linux, Proctom and Proctom, and Microsoft has got a solid investment in open source software for Linux as well as for Windows. So this launch of Sysmon is quite a step forward. Sysmon is obviously a much more complicated and wider used tool. It's used across Windows on millions and millions of platforms, and bringing it to Linux is something that we're quite excited about. Yeah, so the Linux version of Sysmon, known as Sysmon for Linux, is a direct port from the Windows version. It actually shares the same code for the configuration loading and the filter engine. If you're already a user of the Windows version of Sysmon and you're used to making configuration files to configure that, then you could use exactly the same skills on the Linux version, build the configuration files in exactly the same way, and you can expect the event filtering engine to work in the same way as it does on Windows. So obviously the Windows version has a kernel driver which collects the information from which Sysmon makes events, and we needed to rewrite that for Linux. We used eBPF for that, which is a technology that allows you to write safe code that runs inside a virtual machine inside the Linux kernel. So it's kind of like writing a kernel module, but it's entirely safe. You can only read and write certain pieces of memory, and you can only run a very limited set of functions. But with that technology, you can collect a lot of information that is interesting about the system and send that to the userland version of Sysmon in order to make events. In order to simplify that process, I first wrote a library called Sysinternals eBPF, which we're also launching today. This is a shared library that's linked with your userland code that lets you load and control your eBPF programs. And it also comes with an eBPF code library featuring snippets which you can use as inline functions to access the facilities that the shared library offers. Now, the benefit of using this is that we can support any kernel version from version 4.15 onwards, and we don't require you to recompile the kernel with any special options or to install any symbols packages. We currently support a range of events directly ported from the Windows version. So things like process creation and termination, file creation and deletion, network events, raw access read and access process. And we output in the same XML format that the Windows version outputs, but instead of going to the Windows Event Log, we obviously output to syslog. If you've got a theme that can understand Sysmon messaging, which it collects from the Windows Event Log, and you can reconfigure that to collect information from Linux syslog, then it should be able to understand the events that we're outputting because they're in exactly the same format. The code will be available today on GitHub at the URLs seen on the slide, and there are also deb and RPM packages available. Follow the instructions on the GitHub to find out how to access them. Let me show you what that means. If I tail the syslog in this window, we can see we've got our normal system messages that come out. And in here, I'm going to start up Sysmon. with a configuration that is going to highlight all of those events. We can see it loading in the right-hand window in the syslog, and now we can see it's already generating events. If I was to run an S, then we can see in here, this is the XML of the Sysmon is outputting, and you can see things like the command line here, current directory, there'll be usernames, parent processes, etc. But of course, that XML is a bit difficult to read. So what we're going to do is just quickly pipe that through another tool that comes with. And as you see, that just turns it into human readable form. It's just taking the XML and reprocessing it so we can see stuff. So just to give a quick demo of the sort of things that it can do, if we were to go and wget a file, which is the sort of thing like a malware, like a ransomware or a coin mine or something might do, might go off and fetch a file. Then in the right hand side here, we can see the program that made the network connection, the user, the IP and the port. Obviously, that's also created a file, so we can see the file that was dropped here, which is index.html by that process. And one last thing I'll say, I've got here a symbolic link. If I was to just to access the hard disk directory, you can see here we've got a raw access read event occurred against the actual device, regardless of the name that I actually accessing it with. Yeah, so Sysmon for Linux is launched today. It's available on GitHub and in dev and RPM packages, as I mentioned. So now I'm going to throw back to Mario, who's going to talk about Procmon.
Awesome, thanks, Kevin. Super excited to see Sysmon, yet another Sysinternals tool coming for Linux, and especially being as useful and as widely used as it is. Also kind of excited about the Sysinternals eBPF library, but we'll talk a little bit more about that later on in the roadmap as it relates to Procmon. So Procmon, as you know, it's a lightweight system activity tracing tool. We have brought it to Linux, and it's been around probably about a year and a half at this point. Much like Sysmon, it is based on eBPF. We do it slightly differently today than what Sysmon does, but we will be moving over shortly to the library that Kevin was mentioning, which is the Sysinternals eBPF library shipping today. Now, Procmon, basically what it does, it traces all the syscalls for all the processes running on the system. And it gives you things like how long did the syscall take to run, what was the result of it, it gives you the inbound arguments, and it can actually even give you call stacks with a little bit of an asterisk there. You have to make sure that symbolic information is available and frame pointers are actually included in order to be able to get proper clean call stacks. As you can imagine, tracing all syscalls for all processes on the system is going to generate quite a bit of data. And so what we've done to simplify that a little bit is we built a UI around it. It's a TUI, actually, a text user interface. And it allows you to do things like filtering or searching if you want to hone in on specific processes that you're interested in. Just like Sysmon and all of the Sysinternals for Linux tools to date, they are all open source, and Procmon lives at this URL. Now, instead of just talking about it, let me jump in and give you a demo, quick kind of lap around to see what Procmon looks like. So I'm in the terminal here, and in order to get Procmon to begin with, we have to install it. So on Ubuntu, it would be something like this. Now I already got it installed, so I'm not going to run this, but it's pretty trivial to get it. In order to run it, you do need to be sudo, and all you got to do is sudo procmon and type in the password. So up comes the TUI, and you can see here that it's got each of these events that are logged here is a syscall that a process is making, and we've got the different columns here like timestamp, process ID, what the process was, the syscall itself, the result code, duration, and then some details around it. You can see that it just continues to keep collecting events. I'm going to pause that for just a second. You can use F5 for that. And if you wanted to get a little bit more information on any of these given processes, you can just select the one that you want. You hit enter, and you'll notice that we have an additional piece of data here with the stack trace. In this particular case, the stack trace is not clean, likely as a result of frame pointers being omitted, and so you won't get clean call stacks in that case. couple of other quick things. Let's say that, you can see here that I've got process Gmain, I got SSHD, systemd, there's a whole bunch of processes. If I'm interested in a particular one, I can just hit F4 to filter. And let's say I'm interested in SSHD, right? And so now you're actually filtering and you're getting just the SSHD process itself. Another kind of cool thing that we have is stats, F8. That gives you a breakdown of the top 10 syscalls in terms of counts and total duration. So if you ever feel that you're in a situation where a syscall is being hit too often or is taking too long, this is a great way of just finding what that is. Last thing I just want to quickly talk about is the export. So F6, all that does is just dumps all this data into the data store, and you can use, currently it's stored in SQLite, and you can use the SQLite CLI to do your own queries and manipulate the data in any way that you want. So that's kind of a quick lap around for Procmon. Now I'm going to switch back and talk about yet another tool that we have, which is also widely popular on the Windows side of things, and it's called Proctom. And at the end of the day, what Proctom does, it creates a static snapshot of any given running process, right? And a snapshot is nothing more than the state of the entire application being dumped to a file so that you can take that file, move it off of the production machine, and debug it post-mortem to get at the root cause that you're trying to find. We have ability to get these static snapshots on Linux. They're called core dumps. On Windows, it's crash dumps. So we have that capability today in Linux. You can use your favorite debugger, right? You can use GDB, you can use LLDB, and they've got commands to generate these. There's also one wrapper around GDB that just makes it slightly more approachable. It's called gcore. So with that, if we already have these tools, what's Proctom all about, right? And the power from Proctom really stems from its monitoring and triggering capabilities. Oftentimes, when you're running into issues in production, you don't know when the issue is going to happen. You might have some signals in terms of, when the issue happens, we're running high on CPU, for example, but it's completely unknown in as far as when or how it happens, right? And so Proctom, what that allows you to do is say, monitor this process, and when a certain event or activity happens, that's when I want you to automatically generate a core dump, and those are called triggers. Today, Proctom has triggers around CPU, meaning you can specify thresholds for, upper and lower threshold for CPU. So for example, my process is consuming more than 90% CPU. I want you to create a core dump. Similar thresholds exist for memory. We also have a thread count trigger, meaning that if for whatever reason threads start spinning out of control, you can say that once the thread count goes above X, I want you to generate a core dump. Similar with file descriptor counts, and one other trigger that we have that was actually added very recently, super exciting, is triggering core dumps based on specific signals. So if your application ends up getting signals that are unanticipated, or there's some issue in the signaling logic, you can now say, proc dump, monitor this process, and when the particular signal comes through, generate a core dump. Another interesting integration that we have with proc dump is in regards to .NET Core 3.x and higher. As a runtime, .NET Core will allocate quite a bit of memory, going on the assumption that, of course, your application is going to use it. And so when you use the normal mechanism, quote unquote, to generate core dumps, those core dumps end up getting really, really, really big. And that presents somewhat of a challenge in terms of the logistics of managing the core dump. So you've got, let's say a 5 gig core dump on the production machine that you now got to offload onto somewhere else and then use the debugger, right? It turns out that .NET Core has its own dump mechanism. It's not a different core dump file format at all. It's just that it's very selective of what it puts in there. And it only puts things in that it knows is being used. And you can tell .NET Core to trigger a core dump. And that's precisely what proc dump will do in these cases. So instead of generating its own core dump, it simply tells the runtime itself to go and generate it for you, which results in smaller and more manageable core dumps. Just want to make it very, very clear here, though. Proc dump doesn't care if it's .NET Core or any other running process on Linux, right? It will generate core dumps for it. So this is not something that's specific to .NET Core or anything like that. Any given process on Linux, proc dump can generate core dumps from. Much like the other tools, it's all open source, and here is the link on GitHub for where proc dump for Linux lives. So with that, let me jump into a quick demo and show you what that looks like. All right, so the first thing we got to do is make sure we get proc dump onto the machine, so we can do something similar to this on Ubuntu. I already have it installed, so I'm not going to bore you with that. Much like Proctom does require sudo, so we just do sudo proctom. It gives you the banner and it tells you the different triggers that are available and the switches for it. So, for example, the -C, upper and lower, is for CPU triggers, M is for memory, thread counts, file descriptor, etc. So the one thing really that's required when you run Proctom, you don't even have to have a trigger, in which case it becomes an on-demand core dump. But you do also always have to specify which process you want the dump being taken off of. And that's when you use the -P switch followed by the process ID. And there's a plethora of ways of getting the process ID. So I'm going to switch over to this window. I'm just going to run some arbitrary thing in the background. So we use htop. And let's say I wanted to generate a core dump off of htop. So in this case, I'm using ps-a to find my htop instance. This is the process ID. And now I can do sudo procdump -p. And procdump runs. We don't have any trigger specified. It's just an on-demand core dump generation. And we notice that right away a core dump of htop is generated. For the same htop instance, I wanted to say, you know what, when threads go over 5, I want you to generate the core dump. So I use the -T switch followed by 5. Now it's just sitting here and it's not actually producing a core dump. Primarily because likely htop isn't using 5 threads. It would be highly unlikely for an application like htop to use 5 threads, right? So I break out of this and just say, you know what, as long as it's using 1 thread, generate a core dump. And we see right away that Proctom detected through that trigger that there was 1 thread and the core dump was generated. Now these core dumps, like I said before, there's nothing special about them. They're just regular old Linux core dumps. So you can load them up in GDB, LLDB, or whatever other core dump analysis program that you might have. So that's kind of the brief introduction to Proctom. Super, super powerful tool, especially in production when you don't know when certain issues are happening. And so for the roadmap, we've got these 3 tools out there. I'm going to let Kevin talk about what's on the horizon for Sysmon. Kevin, take it away.
So yeah, so version 1 will be released today, and we have a set of events. The first thing we're going to add are some Linux specific events, such as monitoring the BPF syscall, so that we can see if other programs or malicious users or malware are manipulating our BPF programs or trying to run their own. We'll also be adding container support, because in the Linux world, a lot of people are using containers to separate out their applications, and that brings a certain extra level of information required for system monitoring. So process identifiers, for example, are different inside a container than outside a container. And the other thing that we're definitely got on the horizon is to add support for BPF type format, so that we can provide the same functionality on machines that actually have BTF support enabled. This will just give a more robust method of accessing kernel internals where that's available. With the rise of BTF Hub, we might be able to support other systems which don't have BTF and for one reason or another don't support our current mechanisms for accessing kernel internals. Wrapping those things together, Sysmon's got somewhere to go, and with it being out on GitHub, if you've got ideas, then obviously communicate with us via there.
Awesome, thanks, Kevin. For Procmon, built on top of eBPF, and we use an abstraction layer called BCC. With the work that Kevin has done in Sysmon, and today releasing the Sysinternals eBPF library, we are starting work right away to removing our lines on BCC and moving to the library that Kevin has developed to make it easier for us to get a wider distro and kernel support. For Proctom, we are adding support as we speak. You remember how I showed you that you have to specify, a process ID, and that targets a specific process? Well, we want to use the process group ID as well in those cases where your application will spawn a lot of child processes to do various things like handle requests or whatnot. So instead of having to tell Proctom, go off and monitor each one of these individual processes, you can just specify sort of the process group ID, and it will automatically handle monitoring all of the child processes. And the next thing that's on the horizon also for Proctom is .NET counter integration. The way that Proctom today gets all of this data is by grokking procfs, where all processes basically are exposed. Now, .NET has its own counters exposed internal to the runtime, and we want to be able to enable Proctom to be able to work off of those counters as well. Those are a couple of things for Procmon and Proctom coming up. And for resources, here again are all the URLs for the GitHub repos. So Sysinternals eBPF, Sysmon Proctom. This is, of course, all open source, and we would love to get any and all good or bad feedback from you all. And we also, of course, welcome contributions. So if there's something that you're interested in seeing in one of these tools, feel free to jump on and can help out. Thanks everyone for attending this session. We hope you found it very useful. It's very exciting to see Sysinternals tools coming to Linux. With that, everyone have a great day, and we'll catch you next time. Bye-bye.
Yeah, thank you very much.
One of the things collaborating with Mark on both the Windows Internals book series as well as the Windows Internals class was the incorporation of Sysinternals tools to both expose and demonstrate and illustrate internal operating system behavior. There was a whole list of Sysinternals tools that we introduced right up front. Of course, Process Explorer, Process Monitor, prior to that FileMon and RegMon, but also Autoruns, ClockRes, LiveKD was a key tool for being able to explore the internal state of a Windows kernel without having to set up two computers. Proc features, PS Exec, PS Getsid, PS Info, PS Kill, PS List, PS Service, PS Suspend, strings, RAM map and VM map were just fantastic for showing really what was going on inside a process virtual address space and inside the physical address space that the OS and drivers occupied. WinOBJ, I've mentioned Zoomit. And of course, a favorite was the blue screen screensaver, including how to remotely execute that on somebody else's machine. And then during the section on crash debugging, both in the book and in the class, we had a number of experiments using the not my fault executable with its companion kernel mode driver, myfault.sys. We would use it to create various blue screen and system hang scenarios. The fun one, though, was the option that would randomly corrupt kernel memory, and we would explain up front that there's some risk of data corruption rendering your system unbootable, but it's never happened, highly unlikely, and we would assist to repair. Sure enough, at one class at Microsoft, someone had used that option and rendered the system unbootable, and we did repair it. I remember, I think I had to use ERD Commander from Winternals to bring the system back to life.
Hi, my name is Aidan Marcuss, and I work in our Windows engineering organization, leading our work with our hardware and app partners, as well as driving our multi-year planning cycle. Today has been an absolutely incredible day, celebrating the 25th anniversary of our Sysinternals tools with our Windows community. Thank you all for joining us. I'm honored to be here with you. In your day-to-day, we know that you go to great lengths to find a solution. Sysinternals has been an invaluable tool in helping you optimize your Windows systems and applications. The Sysinternals tools have had an immense impact for teams both at Microsoft and in our communities. Tools like Process Explorer, Process Monitor, Proctom, and Autoruns have helped us all to drill down to the issues we have faced supporting our applications on Windows, and now even on Linux. Windows is for sure a complex system. To bring the operating system to life, we partner closely with OEMs and ISVs to ensure that each new version of Windows is the best ever. There are times when things just don't go perfectly, and our Sysinternals tools are front and center in our troubleshooting toolkit. The ever-evolving tools have allowed us to make all versions of Windows more reliable, efficient, and secure. I personally want to thank Mark Russinovich and his co-developers' continual 25-year effort investing in the tools to evolve them to support the amazing new features that each version of Windows delivers. As Windows has evolved, so have the tools. FileMon and RegMon merged into Process Monitor. Process Explorer added support for new security features. And Sysmon was invented to help monitor systems as the world transitioned to the cloud and security became a top priority. The Windows team has also taken inspiration from the tools when creating Windows 11. We've added features available in Process Explorer into Task Manager and other inbox applications. In Windows 11, we've made great updates to fit into your existing management tools and processes. Now that it's generally available, it's really ready for you to dive in. The Sysinternal tools have been updated at the same time, adding support for the new hardware and software innovations that underpin the security of Windows 11. Deploying Windows 11 will feel familiar. Upgrading is like running a Windows 10 update. The familiar management experiences you have in place today will support your environment tomorrow as you integrate Windows 11 into your estate. Windows 11 is for sure the most secure Windows yet, with new built-in security technologies that will add protection from chip to the cloud. Windows 11 provides a zero trust ready operating system to protect data and access across devices. We have worked closely with our OEM and silicon partners to raise security baselines to meet the needs of the evolving threat landscape in the new world of hybrid work. Windows 11 is easy to keep up to date and secure. With yearly feature updates and monthly servicing updates, Windows 11 is ready for the enterprise. The Sysinternal tools will continue to be released on sysinternals.com. The Windows troubleshooting tools will continue to be released in the Windows SDK and on the Microsoft Download Center. You can find tools like the Windows Performance Analyzer and Windows Debugger in the new Microsoft Store. Much like Sysinternals tools, we will continue to evolve all of our tools to support the latest OS innovations. With Windows 11, we are delivering new experiences that support the way people work and learn. By taking advantage of the capabilities available today, you can streamline the way you update, secure, and manage your Windows 11 endpoints. Windows 11 is now generally available. If you haven't tried it out yet, check it out. And while you're at it, check out the great new Windows 11 devices. Thank you all very much.